future is here, and today we're going to see how can we be part of it at the
2024 Robotics Developers Day.
Wow, 2024 edition of the conference. This is the second time me being the host, and I'm excited. And how about you, Rodrigo?
Well, actually, Chessie, this is my first time hosting it. I'm also very, very excited. I think, though, the one that has the most experience under his belt, though, is Ricardo.
Yes, this is the 7th edition of the Robotics Developers Day, and this is my 7th time presenting it. And actually, I remember at the beginning when we started, this conference was even not called like this. It was called like ROS Developers Day. And on those times, I remember that ROS 2 didn't exist, and we were doing a lot of stuff that in order to make the robot...
Okay, Grandpa, let's save the story for the coffee break. Now we need to start because we have a really packed agenda exploring the future of robotics industry and sharing valuable career insights and learning new programming skills together.
Okay. Yes, robotics is transforming our lives and opening endless possibilities for the future. Today, we aim to guide you in how to be a part of that future and advance your robotics career by learning from 12 robotics experts. Our goal in this conference is to help you build a sustainable career in robotics that can thrive for at least 20 years.
Yes, and this applies to all the audience there, the beginners, the students, the experts in robotics, or the people that are thinking about jumping from their current job into a robotics position. We hope that this conference is going to inspire you to learn more, decide to start your own building, or prepare your profiles in order to find better jobs. And for that, we have structured our conference in a way so we can answer 5 main questions. So the first question is, is it now a good moment to jump into robotics? And then the second is, how do I get a job in robotics? Third question is, which programming skills are required to program robots? And then the fourth one will be, how will large language models affect robotics development? The final question we'll try to answer is, should I concentrate on software, hardware, or both?
So in order to get to the answer to these questions, we have included 5 sessions of career advice from the robotics experts who will share their highlights about how you can develop your robotic career in the following path. How to become a humanoid robot developer. How to do robotics consulting. How to have an academic career in robotics. How to launch a robotics startup, and how to get revenue from robotics education. You can see those sessions marked in blue on the agenda.
Yes, and we will also have 5 hands-on learning sessions. So you're going to put your hands on the keyboard and learn robotics skills by programming robots in real time. You can see them highlighted in red on this agenda. We will cover the following topics: programming ROS2 in Rust, ROS2 Gazebo custom plugins, using ROS2 to control a tiny quadcopter, state estimation with Kalman filters for ROS2, and robot arm motion planning with PyRoboPlan.
And additionally, we'll have also 2 practical workshops. On the first one, you'll get a step-by-step guide on how to build an amazing robotics portfolio to get better job opportunities. And then on the second, you will get an overview of the latest ROS2 distribution called ROS2 Jazzy. You can see all those workshops in purple on the agenda on the screen. And finally, we will end the conference with the 2024 ROS Awards ceremony, where we will announce the best ROS software, robot, and developer of the year. You can find the full agenda of the event underneath this screen that is streaming this presentation.
Wow, what a day we have ahead. So make sure you have your coffee ready.
Yeah, I got
mine. Yeah.
Got it.
Before we dive into today's exciting event, let me briefly introduce you to the live conference interface you're using. The main screen you're looking at now is where you will watch the entire conference and all other presentations. On the right side, you can chat with other attendees in real time or interact with the organizers. Use the Q&A tab to ask questions for the speakers. Right below the live stream window, you will find the full agenda, including presentation times, speaker information, and some cool swag available for purchase. If you need any help at any time, ask our support team in the chat. Our whole team is ready to help you. So now let me try to ask a question. Wow. Hey, and what are you doing, Rodrigo?
Oh, sorry, I just want to take a real quick picture because I want to take a picture of our setup and share it on social media because I want to win one of those swag boxes.
So cool. That's very nice, and I also want one. So how does it work?
It's very, very easy. All you have to do is take a picture of your setup that you're using to watch our conference and share it on social media under the hashtag RoboticsDevDay. Again, that's hashtag RoboticsDevDay. So make sure you take a picture and share it on social media. You can see some examples over here on the top of the screen of very nice setups from previous years. So make sure you guys are sending those pictures. And along the conference, we will actually choose the coolest ones, and the selected ones will win one of these swag boxes. And yeah, so all of these amazing prices are actually possible thanks to our sponsors, which are Robotnik Automation, a robotics manufacturer, world leader in mobile robots based on ROS. Usarion, a robotics manufacturer specializing in mobile robots and software for ROS developers. Thanks to Usarion for sponsoring the lunch break game. Robotics Developers Masterclass. This is a full online program that trains you to become a robotics developer in 6 months and gets you ready to work at any company. NAV2. This is the industry standard mobile robot navigation system for ROS2 based robots, developed by Open Navigation. Bitcraze, the company that develops small quadcopters for research and education. You will actually have the opportunity to win one of these quadcopters later today. And Agile X Robotics. It's a robotics manufacturer of autonomous mobile robots based in ROS for education and research. Thanks to Agile X Robotics for sponsoring the Limo Challenge contest.
Wow, that's fantastic. But what is that you called a limo challenge? Is this limo robot you're talking about?
Yes. That's actually the limo robot, and which is the main protagonist in the Limo Challenge, which is a game that we're gonna have sponsored by Agile X Robotics, and anybody can participate. Anybody that is watching can participate. So you will all have a chance to actually win that robot right there. So it's an amazing robot, right? I'm actually really jealous because I won one of those, but I have to host today, so I guess I can't. But anyways, before each coffee break, we're gonna have some coffee breaks. So before each one of those, we'll explain how to participate in the contest. So keep your ears out for that.
Excellent, excellent. So thanks again to Agile X Robotics for supporting this unique contest. All right, so now let's go back to the main stage and let's start the very first session. So now we're going to listen to the career advice from the first expert.
Yes, and in recent times, a lot of companies are jumping into robotics. And they were not interested in robotics before, but now they can see how robots can enhance their productivity or their own management of the business. The problem is that they don't have any knowledge in robotics, so they need the help of an expert. This is where the consultant person in robotics takes place. And what does it mean to be a robotics consultant? Do you need to know hardware and software? What kind of academic background is required? And how do you get projects monetized? And all these questions are going to be answered in the next presentation that is hitting the stage with Denis Stogl. Denis is the CEO and director of Stogl Robotics, a consultancy robotics company based on ROS solutions. Let me welcome Denis Stogl. Hi, Denis, are you there? Hello. What is the situation? We see here. Okay, so we cannot see your face, so we can see here now another person's names, actually. But can you hear me, Denis?
Yes, I can hear you.
Oh, excellent. So in the meantime that they are putting the... Oh, now we can see you. Excellent. There he goes. There is Denis. So how you doing, Denis?
I'm doing great, thank you. How are you?
Fine here with a lot of issues during the conference, but we are solving one by one, and I think that we are ready for this awesome talk with you. And the first thing that I would like to talk is what is Stogl Robotics about?
So the Stogl Robotics is an engineering company for enhanced automation and boost robotic application, how I like to call it. We provide consulting and engineering services to our clients to create completely new robotics applications or improve existing ones. Why I like to tell it's enhanced automation and boost robotics, because we are always like to go step more than the classical automation or state of the industries, since we are coming from the ROS background, and ROS is one important component that we use in our daily business.
And then we can classify your business as a consultancy business, right?
Yes, exactly.
And can you express better to the audience, so for the newcomers, what is a consultancy business?
Yeah, consultancy means that you develop applications and solutions for your clients, basically not your own. Of course, you bring your own idea, but you are developing for other people.
And in this case, it's applied to robotics projects.
Exactly,
right?
exactly.
Exactly. And who are your clients? So can the audience hire you?
Yeah, so our clients are individuals to multinational corporations. Everybody basically who needs help to make robotic solution for 21st century. What I mean by that, it's basically that it's novel, they are open to ROS2, and they need certain amount of complexity. So basically what we are not doing, it's simple pick and place application that you can do with industrial robot. I would even say easier than with ROS. So that's not our place, but our place is more, let's go advance, a lot of sensors, data, robots, and so on.
And autonomy.
Exactly.
Autonomy, yeah. Okay, can you tell us about any interesting project that is not secret and you are working right now, so for the audience to have an idea of what to expect of this?
So the current projects, the past project or some part of past project, you can see also on our website, where we also write a bit more what we were doing there. But actually, from the current project, I cannot give you exact the project, but I can give you the areas, and that's actually, I think, the most interesting part, because they are mostly from the areas where you would never think of that there is robotics or something like that. And when I tell you the area for the audience, it's definitely not what you think, because it's not so easy solution, but many things will be public in the next few months. So then you can stay tuned. Yeah.
Okay.
But for example, we have currently project in the tunnel construction, underground mining area, automation there. Then new applications in car repair shops. That's very cool. Car repair shops automation. It's a big thing that's coming.
Wow.
Then the robotics in construction. Then robotics automation in outdoor logistics, but it's not so, actually there is few complexities there, and we are working on one very little problem, but it's very cool problem, I have to say. This will come in September. You can stay tuned. And also what we are working on, it's our own product, which basically came out from our consultancy. This is the control box based on ROS. The idea is that we can just plug any industrial robot or a machine and have ROS interface to it. So also our clients can better and easier developed using these things.
Excellent. Impressive. So you gave a full list of possible places where robots are applied, and also where consultancy business has a place also in your case. And then that's an idea for the audience there, that they don't know what to do or the next step. So that's the purpose of this conference. So you can see, the audience, you can see some places where you can apply your knowledge of robotics or create one consultancy business. But there are many more, plenty. So what inspired you to start a robotics consultancy business, Denis?
Inspiration is, I think it was just motivation, because I was looking around after, or being close to finishing my PhD. During my PhD, I actually mentioned, somehow I like to work alone. Alone. I like to work on self-defined problems. And consultancy is also part of it. I mean, I find cool in consultancy, you get a problem for other person, but they are expert in their field. They have no idea about robotics oftentimes.
Exactly.
And then you have to figure out how to get this solution to the robot, and that's what I really love. And I was thinking, okay, where I can work on ROS full time. Except the research, I'm more engineer type of person, want to go more into industry, want to really contribute to to contribute to industry as much with Ross as Ross was contributing to research community, to improving a lot of stuff. And when you see then where the industry stands, and that's how it was like kind of natural thing to do that.
Yes, excellent. So that's for a typical a path that people that want to be working on their own projects can take. Because as you express is that there is a problem, but the way that you solve the problem is up to you. So you define your terms, because the client cannot. They can just give you the restrictions on the
Exactly.
right. Okay, great. And then can you explain us a little bit? So you said also that you were finishing your PhD and you wanted to then work, but in some way that you are not hired for a job, and then you have your boss and so on. So what were the first steps that you took in order to get the business off the ground? Because this is not easy. I mean, you start from zero, right?
Yes, there is a long story. I'm not sure if I would do it again, to be honest. I mean, I'm very happy where I am. It's just
yes.
But the thing is, I mean, you really start from zero, and I was very lucky back then that I did one quite important decision. Now it was small but important decision that I decided in April 2020 to join ROS2 control development a lot. And basically becoming there more and more involved and becoming maintainer brought to me also first client. So one of my first client was Picnic. They needed people knowing control. They are known for their Move-It framework and so on, but they also needed control experts. And basically ROS2 Control brought me this first job, and actually a lot of many other clients. They saw us on the open source, how we are active. And basically come to us when they need some help.
That's interesting that you mentioned this, because this is one of the things that we want to propose actually in this conference. Around the end of the conference, we have a workshop for teaching how to create your portfolio. Because in the portfolio, you can showcase your work. And that kind of resonates with what you are saying, because your clients can see your open source things that you have done in robotics, and then they can evaluate, they can understand that you really know your craft, and then hire you. It's interesting, very, very interesting. And then can you tell us about any early challenge that you faced and how you did overcome it? Just one example so that people can understand what to expect from starting their own consultancy business.
Yeah, I mean, basically, I started kind of as a freelancer. Nevertheless, for me, was always the company in mind, to building up the company. So that was also my standing I was taking. So I was also lucky that the clients were open, that I worked for them only part-time, because usually they want to also have people working for them full-time. So this is one of the things basically, that you lose some jobs because you say, okay, I will not work for anybody full time because I'm trying to build something up, make it independent. And it's also then a big thing which we are, I have to say, still struggling, but I think this is just consulting business. You either have too many people or either you have too much to do. So there is fine to hard balance between number of projects, number of people in the company, and so on. But I think this is just consulting life, to be honest.
Okay, and do you have a niche? Well, you defined a niche at the beginning of your presentation, and how did you identify your niche within the robotics industry or landscape?
Yeah, for me, it happened quite naturally. I mean, I'm automation engineer. I was always I really love automation, control, and so on. Then I started to be involved into ROS2 control, and to be honest, everything else comes like together to it. So the first niche was really hardcore ROS2 control things, and now we are slowly extending where we are building, full applications, smaller applications for the clients, and so on. Of course, you have to also connect with other libraries, navigation, Move-It, and so on, always. But this is not our core. Our core is really control. And then everything else, it's building applications. And I mean, currently we are also a bit of pushing, at least locally here in Germany, a lot into industry, so that we really bring ROS into industry.
No.
Even if the clients don't know it, they got from us cells with running on ROS with robots. So that's what I find cool, because I see there a lot of potential for improvement. Do classical industry, but with ROS. That's cool.
Yes, but that's amazing, because that industry is actually a little bit reticent to accept ROS. They want to keep on their old solutions based on industrial robots, and they know that it works. They have the whole environment ecosystem around it, and then how do you manage this? How do you achieve this?
I mean, there is actually multitudes of problems why this happens in the industry. The first one is actually you have to, when you go deep into industry, there is no much engineers. So everybody who is having engineering degree here or something like that, you are very, very rare in the world. I can tell you that. I mean, we are all surrounded with engineers probably every day, but we are very rarely in the world. And you have then technicians who know very well usually one robotic program, one robotic language, and that's why they build it like that. And for many applications, you are happy just to say robot go there, close the gripper, go to the other position, and so on.
And that's
but
it.
now as applications get more and more complex, as they need more sensors and so on, you see how this way of programming robots comes to a limit.
Yeah.
And especially you are having less and less people. You need more and more applications, and having less and less educated people who can do that. Especially the PLC business and robotic businesses, we are also connected a lot with automation. People are, the average age of people are 50 plus. So we know that those developers will basically naturally die out. How hard this sounding, but it is like that. And there is where I see ROS that can actually boost the whole industry, because it can help you with reusability of components, not build constantly things from scratch which take weeks and months. That's
Okay, so what you are saying is very good news for the audience, because they are in this field, and then so they are, most of them, they are very, very interested in ROS. So that those are good news for all the audience. So understand that there is a lot of work for robotics developers.
There is a lot of work. But it's also important, what I would like to tell them, if they're interested in this, such a, what we are doing, low-level robotics integration, going towards industry, having knowledge of classical programming of robots, having knowledge also of PLCs and so on, it's also important, because you can then understand, you often have to upgrade applications of the clients. You don't want to destroy everything what they have.
Yeah.
Because some industries, we are talking, hard money, every second counts.
Of course.
Especially in production. And this is what you also have to take into consideration. But ROS I see as a huge booster of complex, especially complex applications.
Okay, yeah, so ROS will be one of the main parts that you need to know as a skill, but there are others that you mentioned.
Yeah.
Okay, excellent. And then can I ask you, well, actually you think something else. So what services does your consultancy provide? So a consultancy service company, what does it does is to manage a project from 0 to 1, is to send engineers to the office or to the industry that you want to apply. Which kind of services are you providing?
Actually, both of those, what you're mentioning, but I usually put them on the scale, like from consulting, we organize workshops with clients that are often where startups come to us, ask us, okay, I want to build this and that. What should I do? Which libraries in ROS should I use? What is proven, what's not? That's, for example, how to build your stack, because you always end up building your robotics stack, your software stack. Then the providing engineers for develop particular features, or basically build from 0 to 1, or from 0 to version, some version, the small robotic cell with everything what is needed, hardware, software, connecting, thinking about all the parts required for that and so on.
So you mentioned several interesting things. The first one is that you are combining hardware and software in your project. So you are doing both things.
Exactly.
Is that right? Okay. So do you think that there is more importance in one of them, or what would you recommend to the audience that is listening here? Should they concentrate in one thing, the other, or have a pair of learning and understanding of both at the same time?
I mean, it depends what you want to do at the end. For example,
As a
not for
professional,
our-
you mean?
Yeah, I mean, not for our people in our company is important that they understand everything. But generally, for example, for me personally, I love hardware and I love this combination of hardware and software. That's why I love robotics. I need to have, real world touch from my software. And that's why also I have a big affinity to hardware to understand the whole hardware things. Yeah, so you can decide. I find it still, even if you want to be pure software engineer in robotics, some sense of hardware you need to have.
Yeah.
Because robotics is always real world limitations.
Exactly.
You are not developing website where you have all your own little world. You are the god and you can do everything. We have physics, and physics tell you what you can do and what not in robotics.
That's excellent definition. Excellent. You describe so well. Very good. Excellent. And then what about the qualities that you look for people when hiring team members?
So for me, it's actually very important open source portfolio, what you were mentioning. I basically looked at, I don't look much, or we don't look much in the CV. For also nowadays is for us quite important to have already some connection, if possible, to the people through open source or whatever, or some good recommendation. So I would definitely here recommend people not only to build your robotics portfolio. For me, robotics portfolio doesn't mean that you build some small demo of some robot or whatever. This is less important. What I find much more interesting and more important, and it's way harder, is basically that you go and contribute some of the core libraries. You can build your own little demos, but if you love navigation, dive into navigation too and go deep to know every single part of it. I mean, not every, but you can say, okay, I'm very, very good at global planners or something like that, because those stakes are actually where gross profit. It's not that you say, yeah, I have here, and it's different way of learning. When you go into existing project, you then learn also build up bigger projects because you see the structure of the bigger projects, the complexity and so on.
Yeah, and also you learn how to collaborate into a project, which is something very
Exactly.
difficult because, as you mentioned, you are not your own god in your web interface there. You need to push some other code that cannot affect the other people, and then so you have to collaborate in order to have a functionality working where your piece is one of the parts only and don't break the system. Okay.
Exactly, and doesn't matter where you work, where you will work later, or do you want to do robotic consultancy, you want to work within a development team, you want to, I don't know, be application engineer using ROS, you will end up using those tools. And those tools are important, and that's why I find it's extremely important really to try to contribute to existing project. Doesn't matter how little the contribution is. For me, is more value than just say, yeah, I can put together a few launch files and few YAML files. That's fine. That's also a plus. But it's contribute little bug fix to one existing library. It gives you, okay, I dive into a problem and I can solve certain problem.
Excellent advice. And audience, Denis, what Denis is saying is gold pieces. Okay, you are struggling to get a job, then he's giving you the roadmap for being hired. Okay, so he's talking now about being hired in a robotics company, for example, in his company. But this applies also to other types of companies that are not consultancy, but they are developing products and so on. So let me see here. So then you mentioned about the CV also, that not that much. And what about the university titles? What do you think about that? Is that that important in order to get a job in robotics?
Yes and no. I mean, it depends. It depends. I would say I can tell from my perspective and from the company what I see. It's more important what you do and what your track record is. And now it's so easy to build up track record. Of course, you have to do a lot on your free time. I know I've been there with Trust to Control. But this is way more important because showing that you can actually understand complex systems and robots are, because they are complex, and that you can work with such software and so on. It's way more important, I would say, than have academic title, because academic title basically means at the end you were focusing on one very narrow topic for a certain amount of years, and this can help you for certain positions. For example, if you really want to go into R&D departments of big corporations, then yes, okay, this is important because, I don't know, you will work on grasping with a robot and you will be expert in grasping, but then you will usually during this academic pathway, you lose the whole stack, for example, overview.
No, I see.
Which is sometimes quite important, especially if you go into smaller companies, robotic consultancy and so on. It's more important to understand broader things than
And how they
be
interact.
really extremely great in one thing. Yeah, but T engineer is always the best thing. Yeah,
Which one? Sorry.
the T engineer,
Oh.
like now letter T, like you have overview of everything, but you're very good in one field.
Oh,
It's
nice
always the
analogy.
secret.
Okay.
Yeah, the secret sauce.
Excellent. So cool. What I saw is that there are many job requirements that they are asking for a university degree, and in my opinion, that is being used. I mean, it could be useful if you have it for as a matter of not getting rejected from the initial application for that job, because
Yeah.
some of them, some companies, probably the big companies, they say, oh, we need a robotics engineer, and then we need it to have a degree in computer science or in robotics or whatever. And then if you don't have it, I mean, you are discarded off the shelf directly. So having it is just for passing this, but then after that, you need to demonstrate the real thing, which is this portfolio.
Exactly. I mean, what I would say here, it's I mean, university degree for robotics, it's important. But I would say it's less important if it's bachelor, master, or PhD. Or I mean, I think master is a standard, but also people with bachelor, because the thing is, robotics is a lot of physics and math in the background. It's not that you are using everything every day, that you are doing matrices calculations, but to understand your problems, you have to have this toolbox in your head, that you can see, okay, this is what is happening in my problem. That's why I think they are asking for it, just to have this sharpness a bit in math and physics.
That's awesome. Sorry, I think it's awesome how you explain it. Because
thanks.
really, because really, I was listening to you and I think, wow, I have to use this for me to explain, because the people think, oh, but you need to know a lot of math and so on, and then I don't remember how to do the matrix determinant, make the identity matrix and whatever. I don't remember, but I remember the concept in my head that you are saying, and then I understand what is happening because it's actually happening there. But if I have to do it manually, I need to go to the book and check it. But that's not the important thing. The important thing is that you have it, the meaning of those of those operations. What are they doing in the real life, and why you should apply this one or the other one, and that's having this material into your head directly to understand what is happening in the reality.
Yeah, I mean, understanding is much more important than having, I mean, don't tell anyone. I hope this is not recording. But if you give me now to calculate some transformations by my hand, I'm not sure I would manage it. That's why I use TF. But I understand TF very well, and know exactly what is happening inside.
Yes.
So that's important thing.
Exactly. Excellent. Very good. Let me see more questions here. So in your company, you are several people, right?
Yes.
then how do you ensure an effective teamwork and collaboration dynamics in your team? Because what I mean is that do you hire the same type of people with the same skills and then you put them to work together, or you are more in the sense of some specialist, even if they have, you mentioned that you need to have a broad, but then you are a specialist into one. Is more your team in this way, working in this way?
We have actually a mix. We have a mix. We have people who are very good in like what I call integration, where you need to take many libraries and put them together. But also few people who have also PhDs and are very, very good in their domain. So it's mixed. And even some of those people are not maybe so good with TROS, but they are very, very good in algorithms, in control algorithms, trajectory generation algorithms, and so on, everything what is important for us. So it's more, I would not say that we are specifically, filtering out, like say now, okay, we need extremely big skill, because if there is a fit, if there is, for me, is also quite important, if there is personal fit, if there is a good vibe, then we know that we can work with that person. And because this is important, you spend a lot of time together. Our people spend also a lot of time with clients, and it's important that they can also go well with people, because sometimes you have clients who think they know a lot of in robotics, but they don't know so much in robotics, and they try to explain you what to do something, and then you have to know how to tell them that that the things should be done differently, that they would like to have it.
So can I say that is what you are defining is a type of culture, and then your new hirings has to fit into this culture or something, so they have to be more or less in the same culture.
I would say this is a similar thing.
Okay,
it would be
great.
Similarity.
So, well, that's an important point in case that you want to build your consultancy business, is that at some point in time, you will not be able to do everything by yourself, even if you are very intelligent.
Totally.
So you will need to hire some other people. And that's the experience that Denis is bringing here about this topic. That's the reason of this question. And then for your team, so I imagine that sometimes you get a project that is on a subject that you are not mastering, nobody in your team. So what is but you know you can do it, but you don't have yet the knowledge for that. So what is the strategy that you follow in those situations in order to train your team or to acquire the required knowledge that is missing? And I'm not telling about a small part, like, oh, I don't remember this small thing. Okay, so that everybody can do it. Any engineer can do it. But I mean, like another subject you have been always making projects on path planning for arms, but now you need to include the perception in order to grasp things. So you never did that because you were very concentrated on the arms, and all the team is about that. So how would you manage this? Are you just hiring somebody that can do it, or are you going to incorporate the knowledge into your company by doing some special training or something like that?
And there are different strategies. It depends on the timeline. Sometimes you would just buy this knowledge basically from another consulting company, and so on. It depends on the domain. Currently, there are for many domains very specialized products where you can already buy a bit more expensive product, which gives you a lot of functionality, especially in industrial use cases and so on. So it depends, but for us, what is also in general quite important in the company that we contribute to open source, and we have a rule that that everybody should spend half a day a week. It doesn't work every week, of course, on open source development, and there is basically also idea on personal development. This can be testing, whatever, but what I always also tell people, just find something you like, something what is interesting, and go full in, and this is quite important. And also, I mean, we are also quite lucky that people we hire, they have also their intrinsic interest into robotics and so on. They also often then develop skills beside their day job, because let's be honest, 8 hours at a job, you don't manage to develop so much. Yeah, so I think there are different strategies. If it's short timeline, I would buy it. If it's longer timeline, we would then learn it, test it, and so on. I mean, there are great tools in ROS. You build simulation, you can test stuff with the simulation, see how it feels, and then you move on. But until now, it was always that we at least always knew a bit or did something into this direction, or we had immediately idea, okay, this problem I can solve like that because we saw this in different domain or something. You know, we had last year one quite, it was quite challenging project. We didn't do it at the end, but we did it initial work, basically first phase. But at the end, I don't know what happened. The client, the end client, because sometimes you are the like fifth in the line of clients, didn't order or whatever. But this was quite challenging because it was recognizing very challenging object in point clouds. So this would be anyway extremely challenging topic. Yeah.
Okay, yeah, so Denis, you keep giving us gold drops in there, many. Just summarizing, let me summarize one. And it's about that about acquiring the knowledge. If it is long term, you acquire it into the company. If it's so you make the people, and then if it's short term, then it's faster just to hire somebody. And that leads me to the second gold drop that you say, which is about to other consultancy companies. So that's very interesting because we can connect with what you said at the beginning when you started in ROS Control, and then Picnic hired you. Picnic is another consultancy company, and it was hiring you. So it's what I mean here is that there is a possibility for all the audience there to create a consultancy business and collaborate and have like clients between each other in order to achieve a good business. So there is no like a small space that is occupied, and then there is so we cannot fit now the new people there. I think that's interesting.
No, I can say there is way more things to do than we can all do if every one of us would work 24 hours a day. It's
yes.
No, there is no chance to get all the challenges done.
Yes, you're right. We are getting all the time at the construct. We are getting all the time people asking us, hey, can you do consultancy for us? And some of them we redirected to you. So you have it there. So great. Then what else? Let me tell about... So you are, you are a doctor, you are an engineer in robotics, or an expert, but what skills do you think that are required for a person that wants to create a robotics consultancy business? More about technical skills, more about management, more about sales? What do you think about that?
I would basically put everything into one, to be honest. People skills.
Now you are motivating me, the audience, Denis.
Yeah. Now it's. I mean, technical skills are very important, especially when you are starting. I mean, for me, still are important because that's what our core business is. We are solving hard technical problems, which our clients cannot solve on their own. But from a business perspective, from business leading perspective, is actually people skills, because this helps you to build up a team. This helps you to go well with your clients, and this helps you also to do sales and everything. I would say all the other business related skills are less important at the beginning. More important is really to build up relationships with people in every domain.
I see, yes. Okay, so in this conference, we are concentrating more on the technical skills, but in case that somebody in the audience is thinking about creating a consultancy business, then have in mind also to equip yourself with those skills that Denis mentioned.
I mean, you're not doing a business building conference, so I think this is fine that you focus just on technical skills, and this is very important.
Yes.
Yeah.
That is right. And then, but one question important about building a business is about getting some funding. So how did you start your business? Did you have some saved money? Did you get an investment from an investor? I'm talking not about a startup. Okay, so this is not a startup business. It's a consultancy business, which is different. We are going to deal with the startup later with Victor Majoral. But in this business, so how did you manage the initial funding or money that you need to launch your business?
Yeah, I mean, I didn't even need it. So concretely, because as I finished my PhD, I had already my first client.
Oh,
I can
okay.
say the company was basically was profitable from day -10.
Wow.
Before there was a company, there was already a kind of revenue. So yeah, I think this is also why I kind of choose consulting business, but it's also like because I like solve the problems. And for me personally, is like doing startup, doing your own product with very high risk. Yeah, it's not my thing so much. I mean, that doesn't mean that we will not have some products, like I always call them byproducts, which just came out from our consultancy, because you see, you're always confronted with the same problems.
Yes.
With clients. But in general, for me was always this interesting. And basically, if you have like 2 months salaries or something like that, or not salaries, 2 months what you need for your cost of living, you can basically start, because you should be, if you have a good technical knowledge, you should be able within 2 months find first clients and yeah, basically launch.
Excellent. Yeah, so that's one of the advantages of having a consultancy business of your own, is another one that you don't need that much. Actually, even you can be jumping from another job, right? So you are looking for something else, and then when you get it, then you can use it to jump from your current job into your consultancy business, and you get bootstrapped. Excellent. So, Denis, we have so many more questions here, but we are reaching the end of the time. Then I think that we can close here and leave some time for the questions for the audience. Thank you very much, Denis.
Yeah, of course. Thank you also.
And for all the audience, it's now your turn to ask the questions to Denis. So you can see that there is a question and answers tab on this side of the chat. So write your questions there, or vote for the questions that are already written there, and then the most voted ones I will be asking to Denis directly. And then let me see. So here we have a lot of questions. Okay, Denis. So let's go one by one, and then let's see. So I don't even have, but let me ask you one question, because I had it prepared just in case that nobody had a question there. What is your favorite robot movie?
Oh, I'm not so much somehow into robot movies.
Oh, okay.
But I don't know. Nah, I don't know.
Okay, no problem. I have a second one.
I mean, Terminator probably, because it's like from my childhood, and it was like the top movies back then in 90s. So yeah.
Okay, then
Arnold Schwarzenegger, Terminator 2, the legend one.
Okay, excellent. Yes, those are excellent. Also love it. Then let me ask you one question here, the most voted one by Kasuadana, that says, how do you get started with contributing to robotics open source repo? So how do you, I think that his question is that, okay, I see the repos there, but what do I do? So should I contact somebody? Should I just fork the project, solve it, and do a pull request? Can you give an advice on this?
Yeah, so usually you have issues there. You go to the issues, you pick one, and try to figure out solution for it.
Okay,
and the best is you don't have to say, I will work on this issue, because I know many people who said they will work on issue and never worked. Just do it. That's a recommendation. Doing is much more than talking, yeah.
But then you do it, and what do? You do a pull request.
And then you do pull request, and then you then you wait for the feedback or ask for the feedback, and basically at some point, hopefully this will get merged. And just be open, because to be honest, some feedbacks are hard. I also got a lot of months of my work at the beginning burned, which was thrown away, kind of. because didn't got merged. But now I see it was just too complex things, or it was not in a way how it's meant in the library. So just take time to learn and learn from feedback. You will learn extremely a lot.
Okay, excellent. Then let me ask you another question. So from Arushi Kota says, what do you think are the basic skills to a roboticist should know apart from ROS?
I mean, general robotics understanding, it's very important, because ROS is software library at the end, how you solve robotic problems. But general robotics understanding, kinematics understanding, mobile robots understanding, and so on. Physics, math. Yeah.
Okay. Okay, great. Then another one from Rodrigo, who he's here on my side, but he's very well voted. So he says, as a robotics developer, I'm assuming that you use Linux. What are the best Linux tools, in your opinion, to boost productivity in
That's
robotics
very hard to
development?
say. I don't know.
Any
I
that
mean,
you
many
use,
of
for
our
example?
people-
Sorry.
Yeah, I'm not using regular tools. I mean, many of my colleagues use Visual Studio Code, for example. It's very good for development. Well, I cannot use it. I cannot use it. I tried a few times. It's just too much trying to help me, to be honest.
So what do you use?
But yeah.
What do you use instead
So
of?
I use kdevelop, but to be honest, I don't care. I can program ROS in any text editor, and this is the most flexible for me. I was doing
Wow.
this for more than 10 years, so it's kind of,
Second nature.
of course it can boost, but with experience the tools become less important. It's understanding is important.
Yes,
That's,
I've seen the.
I mean, ChatGPT, of course, is great tool for starting. Definitely, I recommend it full-heartedly. I use it too little, to be honest. Yeah.
Excellent. Okay, so yeah, so here I have one question related to your background, because so the first one is from the audience, okay, from Josh, that says, what is the author's name of the book Robotics Behind You?
Yeah, this is the classics, robotics classic. It's the Springer Handbook of Robotics. It's from Khatib, Siciliano and Khatib. I mean, this is the Bible of robotics.
Sama Khatib and Bruno Siciliano.
Yeah, exactly. This comes every few years comes the new version of there. It's like very thick, like really thick.
Oh, yes, yes. Okay, so that's something that you must have in your desk.
I mean, it comes handy, especially when you go into some special problems. You have a lot of areas of robotics there just to get ideas and understanding. Yeah, it's good to have.
Excellent.
It's not that I read everything. I just go to pages which are important for me at the moment.
Yeah, and then another thing is about this plaque that you have there that says Ross Award. What is that? Yes.
Yeah, we got last year, I think. Last year we got the software of the year.
The best ROS software of the
best
year.
ROS software award. Sorry, yeah, exactly. ROS to Control got it.
And you are the main developer together with Benthe, right?
Yeah, I'm together with Bence, the maintainer, and he said, okay, we can put it here because he won the best presentation, I think.
Yeah,
award,
the best speaker.
Okay. Best speaker, yeah,
as a speaker, yes, of the conference also. Okay, great. Then I think that now it's time to finish, and then to thank again Denis for his contribution. Thank you very much, Denis.
Thank you also for coming. Nice talking to you, and see you at ROSCON.
See you at the ROSCON.
Yeah,
see you at the ROSCON. Bye-bye.
Yes, thank you, Denis. Very, very nice presentation. So now, dear attendees, please, now you should see a small box in the chat where you can actually rate the speaker. So please take a moment, everyone, to rate Denis, because at the end of the conference, we're going to be picking the best speaker of this year's conference. So please take a moment to rate Denis.
Yes, it's still appearing. It still hasn't appeared. Just a second, because we have it's a rating box. So this box is going to appear after each intervention here, so you can rate the people based on your likes, and at the end we'll get decided the person that is the best here.
Great. So before the next speaker hits the stage, let's have some fun.
What do you mean?
So we're going to do a quiz prize right now. So the winner can get a super swag box with a I'm a robotic developer T-shirt, coffee mug, and stickers. So how does it work? We're going to watch a 5-minute video about how teachers can easily create the ROS project to students. So at the end of the video, you will see a question related to the product. And the first person who answers correctly in the chat will win this swag box. So you may need to go to the page of the sponsor to get to the answer. And now let's see the video, and the next speaker will be back in 5 minutes.
See you soon. All right, everyone, welcome back. I see a lot of answers there in the chat. But before announcing the quiz of the contest, I want to let you guys know about the next presentation. And this will be a hands-on learning session. So this means that you need to open a robot project so you can practice with the speaker. And so you can click on the open ROS-check button besides the name of the speaker, right here. By the way, if you have two screens, it's a good thing because on one, you can put this main screen on, while on the other one, you open the robot project so you can follow along with the speaker. And some of you may have the project loading for a while. You just need to wait a few seconds. So don't worry, don't get nervous, it'll open up. And yeah.
All right, so going back to the quiz. So let's see, the winner is Robert Grubelski. Congratulations. So our team will contact you for the shipping information.
Good speed, good speed.
Okay, and now, great. So let's go to the next session. So we know that quadcopters is a technology with a big future. Actually, I think that we are going to have in the future a lot of drone delivery in our cities. But the problem of the robots, of the quadcopters right now, is that they are very big, they are very expensive, and they don't work with ROS. But none of those problems are in the quadcopters that are developed by the company Bitcraze. And this is the robots that Bitcraze creates are quadcopters, especially for research and education, and they are small. So today we are going to have a lesson with Kimberly McGuire, who is one of the robotics engineers at Bitcraze, and she's going to teach us how to program quadcopters in a basic stuff with ROS2. So thank you, Kimberly, for coming here to the stage. Hello, Kimberly, are you there?
Yes, I'm here. Are you able to hear me?
Yes, we can see you. And then, hello. I think that you cannot see me myself, but anyway, so I'm super happy to have you here. Then we are going to start with your presentation. So can you please share your screen?
Of course.
Yes.
Are you able to see my screen?
Yes. Yes.
Awesome.
Okay. So go ahead. The stage is yours.
All right, great. Thanks you, Ricardo, again, also for inviting me to give this talk or this tutorial here at the Robotics Developer Day. Yeah, like you said, my name is Kimberly McGuire. I'm a robotics engineer at Bitcraze. We're the developer of this small quadcopter called the Crazy Fly. Yeah, so it's going to be a tutorial. So I'll try to, or like a skill learning session, as they call it here. So I'll hopefully be able to learn you or teach you a couple of things. Among those things is an introduction to the multicopter plugins that are natively present in Gazebo, how to add velocity control and able to control it with ROS2, how to add sensors to your model and read them out in ROS2, and how to make a simple map out of that. And yeah, perhaps also to show that on a real platform as well. So my understanding, are you guys still able to hear me?
Yes. So
awesome, great. Yeah. I had I got an error. Okay.
Okay. No problem.
So the preliminary knowledge that I think that you should at least know to kind of follow along as you can is that you should have some basic knowledge on ROS2 aspects, like for instance, like ROS topics, ROS services. Perhaps you might have touched Gazebo a little bit, or you followed one of the courses here on the construct. So this ROS-ject, if you're following one of the hands-on passes, is configured to be on ROS2 Humble, and it has Gazebo Fortress enabled in there as well. So yeah, so this presentation will also be showing some demonstrations on a real Crazy Fly quadcopter. So that is that's the one that we at Bitcraze have developed for research and education. So if you happen to have a Crazy Fly with you with a positioning system, and you've prepared it to run this ROSject, then that's great. But you don't have to. I would actually advise you, especially with perhaps like the severity of the servers, maybe to cut the construct some slack and maybe try them out later. But it's absolutely possible. So, all right, so that's the intro out of the way. And first up is part 1, is a bit about quadcopter dynamics. And we're going to forget about ROS2 for a bit, and let's just look at the Gazebo simulator for now. I'm talking about the new Gazebo, so not Gazebo Classic. I have here some codes or like some instructions or commands that I can do in the terminal right here. And then I'll start up a Gazebo simulator with a quadcopter model. It might be for some of you, if you're just opening up your ROSject for the first time, that it has some time, that your simulator might need some time to start up. But at least you'll be able to see it here already. Let's zoom in a bit to right-click on the Crazy Fly and move to. So that kind of looks like a standard quadcopter. It's based on the X1 quadcopter of Gazebo Fuel, but it has like a Crazy Fly skin on it. So it's so that's kind of like what it looks like right here. So this is based on a simulation model. So if I open up the code editor, which is this symbol right here, which is kind of like a visual codes editor that I use here, we can perhaps take a bit of a look at the model itself. So you can find that in ROS2 WS in source, and then you can look at ROS GC Crazyfly, ROS JC Crazyfly description, and model. This is the part that I had to source in my terminal before in order for Gazebo to find it. And yeah, practically, it's not maybe as complex as like an armed robot. It only has like 5 features, which is a base link that is connected to 4 motors with a revolute joint, so that you can kind of see right here. So like M1 is motor 1, motor 2 is all connected to the base link. And what is perhaps more important, because you don't only want rotating motors, you want the motors to actually do something, you have this plugin called Multicopter Motor Model plugin from Gazebo, where you can actually give it some aerodynamic characteristics, which means is that if the propeller rotates, it will actually generate an upward force, which we call thrust. And that's pretty much kind of like the basic of how you can make a Crazy Fly or quadcopter fly. So you have 1 plugin per motor, as shown right here. So let's open up a shell. And yeah, let's see. So this is where the Gazebo is running from. So let's open up a new one. I will just copy paste this part of the commands and open up the Crazy Fly simulator here. All right, so let's see what happens if we spin those motors, shall we? Ah, it spins right away. I have noticed that sometimes you need to do this command a couple of times for it to react on the Gazebo side, but for me it worked right out of the box. Awesome, so the propellers are spinning. Great, but it's not flying, really. So let's change that a bit. How about 100 RPMs machine? Yeah. Let's crank that up a notch. Let's just see it happens. It's in simulation anyway, right? So 1,000 each. Ah, it's not really flying yet. Oh, where did it go? Uh-oh. I lost my simulated quadcopter. That's not great. Okay. Yeah, let's check the pose a bit.
So,
Ah, it's going all the way up. Yeah, that's whoops.
Can I help you?
I did that on purpose, actually.
Ah, okay.
Yeah, I told you. Because this is kind of a lesson in safety. Because imagine if this would happen in a real quadcopter. If I just tried it on my quadcopter right here, it would have hit the ceiling. Or if you would have done it outside, it would have like, well, go up all the way in the air, hit a bird, hit a plane. So that is extremely dangerous. So yeah, luckily we tried it in simulation. That's the power of simulation. And also kind of like the main difference between quadcopters and ground-based robots. If I would stop the motors of the simulated quadcopter now, it would just fall out of the sky. Yes. So I was locked out. Hello?
Yeah, it looks like we are having some problems here in the login.
One moment. Let me just okay, let me just
So
do that here. We'll solve this. Constructs.
yes, so what are you doing there? Because the screen that shows is very strange.
Yeah, it's an VS Code on my computer.
Your own computer. Okay. So
exactly. If everything fails, then that's perhaps what we can still do. But I'm now currently logging in. Let's see the time, perhaps.
yes. So can you try again, please?
It's currently still yeah. One moment. I'm almost there.
We cannot. Yeah, we cannot see your screen. Yeah. No. Sorry. Yes. Okay.
Yeah, I'm not. It's taking a long time.
Yeah.
So, but we'll get there. So
Okay.
yeah, I guess like I can just keep on talking on the like.
Yeah.
That is unfortunate. Yes.
Yes, I'm sorry about that. So it looks like we are having a lot of requests, and for some reason, so there has been an overloaded on the database, and we are trying to solve it as we are speaking here. And then the same happened to me actually. And then I was monitoring your project and following you, but then I also got kicked off. So
yeah.
At least
apologize to everyone for that.
It's not your fault. It's not your fault. It's our fault. It's our fault, definitely. But as you can see, the system doesn't discriminate against the speakers or anybody else. So we are suffering all the same thing.
We're all affected by
the same boat.
As it seems.
Yes. So what can you tell us about Bitcraze?
Yeah,
so what are you working
let's
now?
turn this into a tiny interview then. Yeah, so Bitcraze is a small company that is located in Sweden. So like we're kind of known for the Crazy Fly. That is this one right here. But we also kind of like do make expansion decks for the Crazy Fly so that they can do some positioning with a flow deck. I'm currently showing it with the lighthouse positioning system, which I can probably also give a long talk about, but maybe not now. And that is actually a positioning system that's based on virtual reality. That's also kind of like the bundle that we are giving away for one of the for the price for the prizes that you can get for participating with this Robotics Developer Day.
Exactly. Afterwards, after your presentation, so we are going to show the video about Bitcraze and all the amazing things that you are doing. They are going to love it because the images are spectacular of the drones in different situations. And the winner of the question at the end of the video, they will win your package that your company is providing, which is the tiny drone, the real one with the place for recharging and also the positioning system.
Exactly. Yeah. So so it is possible to recreate all the demos that I'm going to show to you right now.
Yeah.
Hopefully.
Yes.
Let's see how things are going.
Yes. So let me ask you. In the meantime, so let me ask you some questions related to the.
Sure, of course.
So,
so in any case, I can probably skip over a couple of things just to get to the end. But once because I guess we need to be a bit straight on time. But we
Yes.
can.
Yeah. Don't worry. We'll take charge of this, and then I will guide you on this
Okay.
purpose.
Yeah,
Okay.
sounds
Don't
good.
worry. Don't worry. So let's wait that this. Let's hope that this problem is solved quickly by the technical team. And then let me ask you one question about. So what are the main applications that your customers are using the quadcopters for?
Yeah, so the main applications I would say is like it used to back in the day. It used to mostly be people that like to develop by themselves, like the hacker society. But it's mostly the demographic has changed now to researchers that use it for their own research. I myself used the Crazy Fly also for my PhD research, where I had like a swarm of them flying through an indoor building by themselves, and so that was my PhD topic. And people use it for like control theory. They use it for swarm research, like swarm robotics research. They use it for single drone based autonomy, which I'm hopefully able to show a little bit. Also, there's also quite a lot of people that use it with ROS as well. The Crazy Swarm 2 is the project, at least the Crazy Fly server that I want to show to you. I'm just going to refresh.
Yes, and then in the demonstration that you are going to use, because we were preparing this together, so kind of I know what is coming, but I was amazed of the demonstration that you were going to do, and all the audience also were always able to do it together with you by using the project, which is about this tiny drone doing a map of the environment by itself. So can you tell us more about this application?
Perhaps maybe, well, this is reloading again. I can maybe show a picture or a video.
Yes, or a video that you show me. Yeah, that would be awesome.
Yeah, so I've also showed, I also had a recording of my earlier rehearsal as well.
Yes, because you prepared that for the case of emergencies, actually.
Yeah, exactly. So this is one of the demos, spoiler alert, that I was going to show. Hopefully still are able to show. Oh, wait, maybe I can get in now.
Oh, okay.
Yeah.
Let's have a look. Let's see if this is getting in.
Yeah. But yeah, so like you see here, the ARF is open and with like the mapping topic on. The Crazy Fly has a multi-ranger that has a range sensor that is in 4 different directions. And then you can, with teleopt, rotate it a bit around, so it can create the map within the environment as well. So that's really cool.
Wait. But can you tell us about the sensors? So you are showing there on the screen the map, right?
Yeah, exactly.
It's being created by the Bitcraze, but how does it that? So which sensors? So how did you do it?
Let's see if I can kind of show a. Yeah, it's maybe a bit difficult to. Oh, maybe it's here. Like you can see it maybe here.
A little bit lower on the camera. Can you put it a little bit lower on the camera? Yeah, that one. Yeah, we can see it.
So it's like a range sensor in 4 directions.
And this is an add-on. Like, this is an add-on that you can put on the Crazy Fly, right?
Exactly. Yeah. And then you can do some cool things like making a map. Like you don't need a very expensive lighter for that, but it's it's like at least like it's great to kind of like show the basics. And people have done research of actually doing full SLAM with such a sparse lighter as well. So those are also really cool videos if you look them up. There you go. I think we're getting somewhere.
Okay.
Let me just take a quick look at the time.
Yes. So don't worry. Don't worry.
I think I'll be able to show still some cool stuff, but I might need to skip a couple of things.
Okay, great. Go ahead. So.
But it's still loading, so we can. If you have any other questions.
Yes. Okay. So what I want to stress on that is, so the map that you are showing for me is impressive because of several things. The first thing is that it's made by using only 4 rays, right?
Yes.
Because people is used, I'm stressing this point because it's important, because people is used to use the LiDAR. So they think, okay, let's do a map with a quadcopter. Let's put a LiDAR on top that scan, and then the battery, and then, so how can you manage that? But in your case, this solution is very simple. in the sense, I mean, simplifies a lot because it's only using for infrared rays, right?
Yeah, exactly. Yeah, so it simplifies it quite a lot. Like, you know, it's that is already enough to make some kind of map. But of course, you have less information about the environment. Like packages like navigation, like nav2, for instance. Like I've interfaced with things like that, but it has a little bit of issues with how do you call it? Yeah, actually doing the localization part of that as well. That is quite challenging.
Yeah,
To
I
do
can
that from
understand.
like packages that are meant for.
For
Oh, okay. I'm
AMCL.
kicked out of my project again. Let's try it again.
Okay, let's go.
Yeah. So that is kind of like that's kind of the problem. You're not able to really do for some good localization. Luckily, I have a positioning system here, so that is not really a problem for me. But if you have a quadcopter flying in an actual real environment without any predetermined knowledge, that's maybe a little bit more challenging.
I
Yeah.
see. I see. So in this case, you are using the localization provided by your positioning system in order to create the map.
That is kind of providing the odometry for the map building. But like in SLAM, you have simultaneous localization and mapping.
Yes.
So right now it's pretty much only doing the mapping, but it's still fun.
Yes.
Yeah.
And we are going to do it. So we are almost there. So has your project already started? Is ready?
No,
Not
it's
yet?
not.
Okay.
It's always kicking me out.
I see. I see. So I think that we have those problems. Then maybe. So in the meantime, let's.
Yeah, I can show another video.
Yes,
perhaps.
please.
Like and in any case, if we still 15 minutes before time don't have anything at all, I can show a couple of things on my own computer.
Yeah. Sure.
And then at least we have something to show.
Yes. Perfect.
So this is the other demo that I want to show you. Is just like, okay, the mapping is one thing, but how do you generate the map, right? Like how do you do exploration in an environment that you don't know beforehand? You make the map first for yourself and navigate into it, or you can explore.
Yes.
And that is kind of like, this is a video that I'm currently showing in the main screen, where you can actually see the crazy fly doing wall following. It's kind of similar to robotic. How do you say, like these robotic vacuum cleaners?
Yes.
With lidars, like
Yes.
they usually don't have a predetermined map if they're just placed in a new house. So that's kind of like very similar. What they do is kind of they go around all the walls, and then and then they just make the map while
at the same time
they're going. So there is project again. We have about 20 minutes.
Yeah,
Let's
let me
how
see.
far,
It's 37, so we should end. Let me see. It 55. Yeah, we have 20, 50, 60 minutes.
All right. So let me just get a recap of what I've been at. Let's say when we last started. So like. We had a gazebo simulator, we had a quadcopter. I gave a little bit too much trust and then goodbye. So that was to remember that be safe with your quadcopter. It's not a wheeled robot. It will fall out of the sky, or be safe. That's why we have a simulator. So let's see like how far we can get with this. But at least for the simulation, I would need to also not only have trust, but also provide some form of control. This is the multicopter control system for velocity control. It's already pre-tuned before, but that's I can unfortunately not go into it too much. So I would advise you to look at the API documentation of Gazebo and the multicopter systems. So so now at least my simulator should be able to fly a little bit better and not fly away. So let's just start up I'm just going to build it again with a ROS2 and Gazebo bridge. That's all part of the code, and hopefully Kokon will build. And it's building right now. If you've run through the starting tutorials of ROS, then you are already familiar with those with those comments. So yeah, then we should have actually something that's a crazy fly that's able to fly a little bit more stably. So I'm just going to show that real quick, but not in much detail. So let's give it a twist message to the controller, and let's see what happens. So it will go up with with 0.1 meters per second, which is not very quick, but at least it's controlled. It doesn't fly away. So I'll just give it a 0 velocity command, and then it will stay nicely in the air. Awesome. I don't expect you at this point to follow the tutorial that quickly. Unfortunately, I have to go pretty fast, but you can refollow this, at least this project afterwards.
Yes, don't worry about that. So just go do it yourself.
Exactly.
Yeah.
So like I said, I'm going to show it also on the Crazy Fly, but I'm going to show that for a later demonstration because I'm really little on time. So once I make the actual hardware demonstration, I will go through what I'm actually going to show to you. So we have, at least for simulation, we have now a more controlled quadcopter, right? So it's not flying away, it's able to respond to velocity messages. Now we're at the place that we want to be, to at least make it act like a wheeled robot, perhaps. So we add this tiny lidar that I've already showed on the camera before with the impromptu, let's say, the impromptu interview. And here it's a GPU lidar Gazebo sensor that has like 4 range sensors in all directions. And what I'm going to add that is to the base link of the Gazebo simulator. So I'm going to put that here. Awesome. And I'm going to show some simulation mapping. So first, Brazenham is a pip package that needs to be installed because that is something that the simple mapper node is not one of the nav2 or OrbSLAM packages. We use our own package that we have installed, or at least like we have on this project, which is the simple mapper one. And then if you would open up Gazebo, I don't want to rename it. I want to maybe open up Gazebo again. Did I? Yeah, there you go. At least you'll be able to kind of see the lidar visualization right here. So you might need to reload it a bit. There you go. LiDAR result. But there's not a lot in the environment to map. So let's change that. Let's add some walls to it. And that is not done in the Crazyfly model because that's the model of the Crazyfly. You do that in the world. So now I add 4 walls to the world. And then I build everything again to make sure that everything is properly assigned to the install folder on your workspace. And now you see a couple of walls. Well, let's do some mapping, let's say. So I have now, because I've just Cocom built it, I can start up a mapping node. And then I can show RVis too, if everything works. Right, let's add a map. That looks nice, but a bit empty. Let's change that. I need to make it fly a little bit. Let's do that. Okay, so I can make the Crazyfly fly, make stop in air, make it go forward, maybe a bit quicker because we're low on time. And I hope we don't crash it. Luckily, it's simulation. Yeah, so it's a bit, you can see the crazy fly right here. I hope it's not too small. It also needs to be not flying over the walls in order to map it. And then it goes all the way like there. I guess you guys get the point. I'm now currently controlling it with teleopt in order to do the map. But the crazy fly hasn't, or the simulated crazy fly hasn't crashed yet. So there'll be maybe, if I look at the time, yeah, a good opportunity maybe to show this on the real platform. But yes, kind of that's most important part, of course. So yeah, I would have been sad if I wasn't able to show you guys this, and I have a couple of extra demos planned. But let's see how we do on time.
Yes, you are on time. Don't worry. You are doing
Awesome.
excellent. And this is the main conclusion because it's when you are applying this to the real robot.
Yeah, exactly. There is some more concluded parts. I went through it very quick, so I should have enough time for the last part as well, to show a bit of autonomy too. I'm just going to restart the Crazy Fly, and I am also going to change, let's say, the camera. Because I have a nice camera setup, I don't want to move my computer and to show it to you.
Let's see if we can combine somehow the camera. Okay, yeah, now we can see you in the camera, yes.
Yeah, exactly. So this is the meeting room. This is my my life now. Let's see if we can. I've now restarted the Crazy Fly. I'm now going to start the server outside of this ROS-ject. But if you start a ROS2 node on your computer or a robot that's connected to, that's connected through this part from the ROS-ject, then you're able to control it from a web shell in the ROS-ject as well. So yeah, let's do that very quickly. I can also control it with teleopt twist keyboard, just like I was able to with the simulator. And let's make it take off and hope for the best.
Okay, let's see.
There you go.
There it goes.
Yeah,
and you are controlling,
kind of
now
right?
we cannot see your screen, but we can you switch now to the, oh yeah, so this is your camera on your laptop, and then we can see the robot there. Awesome.
Yeah, exactly. So this is not my this is my phone
your
camera.
phone, okay, your phone camera.
Yeah. So it's
and you are getting the data on the ROS-ject. Sorry.
Yeah. Yeah, the ROS-ject, I'm just controlling it a bit. Maybe I'm going to start up a how do you say, a mapping on my ROS-ject as well.
Yes.
So you can switch back if
yes,
you.
Sure.
Yes.
That would be awesome.
So I'm going to start up the mapping nodes. Let's see. So it's mapping. Obviously, you don't have to have this many printouts, but I like it for debugging myself. And let's start up on RVis 2 as well. Yeah. Oh, whoops! I didn't save it. Save this, but that's fine. It's very easy to get it. Oh, there you go. It's already started the map. It started without me. Too quick. Too quick. All right. Let's make it rotate a bit, right?
Yes.
Ooh.
Awesome. Getting the map. So that's just to remind the audience. So this is inside your ROS-ject, and you are getting the data from the real robot.
Yeah, exactly. Yeah, so I'm controlling currently the real robot from my computer. So just as a kind of like a reminder to everybody is, oh, one of the walls went down. I need to fix that before I show this next demo. But it's not running ROS on the Crazy Fly itself. But there is a really cool embedded project called from eProsima that put micro ROS on the Crazy Fly. So I have the link right here in the notebook. But that is, but currently the Crazy Fly is being controlled from a ROS server on the computer. But it doesn't mean it doesn't run ROS. It doesn't run natively ROS. But yeah, that is just a very quick explanation that I had to skip. Awesome. Let me just take it down and maybe prepare for the last part. Fortunately, I had to, I think it's most important for me to kind of show you the concept and then always, let's say that you're able to perhaps try out the ROS-ject for yourself as well. So you will be able to go through all the code. There's no problem. It's all going to be available. And I also have a GitHub repository outside of that you can also try out your project. But let's first disconnect again. I just want to try something out in simulation first. Because yeah, mapping is really cool, and it's pretty cool on such a small platform with such a sparse slider. But like what I said before, also in the interview, is that wouldn't it be cooler if you're able to navigate without a map and generate a map while you're at it?
Yes.
So that is kind of like the true part of like exploration autonomy, right?
Yes, exactly.
Yeah. So that is. So I'm just going to.
Because so far
restart.
you have been doing moving the robot using the keys, right? You're controlling it.
Exactly.
Yeah.
Exactly. So that is, and that is that robotics? Maybe. Well, I feel that robotics needs a little bit more autonomy.
Yeah.
I'm just still disconnecting from the Crazy Fly, so let's hope that everything goes well.
Okay, I don't expect the best in there.
All right, something went wrong.
Yeah.
Right.
Yes. So my team is doing a full reboot of the system, so maybe that's because of that. So
yeah, exactly. In that sense, perhaps if we're not connecting to it anymore, I can still show the simulation. But I'll just turn off the drone just to be sure, because to make things easier for myself, it's responding to the same things.
Yes. Okay.
But maybe not the safest. Please don't use the same topic for velocity command for a real crazy fly and a simulated crazy fly. Just,
why? Why?
Pro tip.
Why?
Because if you happen to work on simulation and then you just suddenly forget that your drone is still on,
yeah,
then you might also send it to your actual drone as well.
Yes, exactly. And then, and then you can make something crazy because the real environment maybe is different from the other one.
Yeah, exactly. So that is just. So I'm not able to disconnect from my computer, but that's fine. I have dealt with this before. So I'm going to go through the autonomy part that I've told you, and that autonomy part is just very simple. It's going to be wall following based on the multi-ranger. Just kind of like you technically only need 2 multi-rangers in order to do wall following, and that's kind of how it here goes. It rotates when it hits a wall, and then it goes around a corner, right here. So. Yeah, there's a couple of nodes where you can, which I don't have the time to go through all the codes, but you can find it all like the wall following node here and the simple mapper right here in the project.
Yes.
But hopefully we'll be able to show it to you.
Let's see, with a little bit of chance, the whole system is rebooted and we can reload it. And with the bad chance, then let me ask you some questions in the meantime.
Oh, I'm already connected.
Okay.
That went quicker than expected.
Okay.
Yeah, the only thing is that what I'm hoping for is maybe that's the yeah, I guess like I didn't. If it was saved from the last position, then.
Okay, excellent.
Oh, whoops.
I think that you need to launch it again, but now the system has been rebooted, so it's going to work without a problem.
Yeah. All right. I thank everybody for being so patient.
No, I'm so sorry about that. That you are suffering this and how much
it's fine.
preparation.
It's a good challenge.
And your reaction is awesome. It's awesome. So thank you very much.
So it's I guess like this is also kind of a lesson in the demo effect.
Yeah, well, you know that we are doing this. So our conference is about real demonstration in real time, and you went harder as more so even harder than most of the people, because you are going with the real robot, not just the simulation but the real one, and then you nail it.
Yeah, so. Exactly. And yeah, so like the complexity is not helping, but I'm committed to finish all the demos before the end.
Go for it. You got it. You almost got it.
We're going to do it. Okay.
Wall
following. Wall following is awesome as long as you have walls and range sensors. So I'm not going to go through the code. I'll leave that up to you guys. I'm going to show it first in simulation because we like safety. And yeah, so let me just first bring up the Crazy Fly simulator. I hope that everything is still in the same state as when it just closed down, but I'm just assuming it is. So let's launch up the Crazy Fly simulator with walls. There are walls. Awesome, awesome. Everything is going swell. Okay, and then I'm just going to very quickly make it take off with the tele op. So just to make sure that's a bit more near. There you go. And then I'm going to start the wall following. So a lot of, as you know from me, a lot of printouts. And it's actually going in a different direction, but let's see if it's able to react on it as well. Actually, it's it seems to be not working, but that's fine because the real thing will work. It's actually responding a little bit differently. Oh, it's actually doing the wall following. Ah, phew. Okay. No, nothing wrong. Nothing wrong. It's just that the simulator is probably a little bit running a bit faster than I'm when I prepared this project. But that is perfect.
Yes,
Okay,
that is
so wall
right, because
following
you
is
have a more powerful computer.
exactly. So currently it's doing the wall following. Let me just make it go a little bit closer. Maybe make it follow it as well. So it's using the range sensors for that too. But actually what we want it to do is also to do mapping at the same time. So let's start up the ROS2 simple mapper again. Let's open up RVIS2 as well. And add the map. And then you can see, if I make this a little bit bigger, that it's generating the map while it's going around the room. Technically, there's a small bug in here. It should also generate a map when the sensors are not detecting anything, but I leave that to an exercise to the people that are actually following this project. But yeah, it's kind of like making a map right now, and I'm not doing anything, no hands.
No, very good.
So yeah, let's close everything, and let's also show this on the real Crazy Fly.
So what are you going to show right now, just for the audience that was disconnected a little bit about it? What are you going to show on your real Crazy Fly?
On the real Crazy Fly, I'm going to show exactly the same thing. So what I'm going to show is that I'm only connecting to it from my computer, but the wall following node is exactly the one that I'm using in this simulator right here from the ROSject. So the ROSject is controlling the drone completely autonomously. So that's what I'm going to show.
Excellent. I'm excited to see it.
Let's put the Crazy Fly back as well. Maybe change the meeting room. So we can show this in time.
Now we can see your environment.
Exactly.
Don't worry, you're on time. Don't
Awesome.
worry, really, don't worry.
So yeah, so this is then the environment. I'm going to make a takeoff like I did before with the teleopt from the ROSject. So wait one moment before I need to kind of see if the server is on. And also, let's just check if any topics are being... Oh, topic.
Can you show her screen? You have to be switching about.
So yeah, there you go. So you see you see all the topics from the real Crazyfly being received by the ROSject. So that's awesome. So that means is that we can control it from it as well. So let's make it just simply take off. All right. And then, of course, like before.
Now go back. Sorry.
Let's make it follow a wall. And if you go to the camera now, you can kind of see it Let's see if you're able to see it. Yeah, there you go. Navigating completely by itself from a node that is running from the project.
We can see it. Awesome.
Yes. Oh wait, of course. We're forgetting one very important thing, which is maybe you want to do some mapping as well, because that's also very important. And let's also very quickly open up RIS.
Switch back.
Yes.
RVIS 2 as well, because we don't want to miss this.
Vamos a ver eso.
There you go.
Yes.
So now I have a real crazy fly. I'm not controlling it. See? No. Hands-free. And it's navigating autonomously. It's generating a map while it's at it. Yeah, this is kind of what robotics is all about, right?
Awesome. It's awesome.
Something that's able to control itself, move autonomously based on its own sensors, and do something useful while navigating in an unknown environment. So, yeah.
Awesome, awesome. So thank you very much, Kimberly, your amazing ending of the demonstration with the real robot, moving autonomously, creating the map, everything in ROS 2. Thank you very much, Kimberly.
Yes. I have some closing words, perhaps. Let me just grab the...
Yes,
the
definitely.
crazy fly real quick.
Yes, so we are seeing how you grab it from the air right now.
Yeah, exactly.
So-
Like, you know, there's a way for me to safely land it, but currently the crazy fly luckily is safe enough for me to do these kinds of things.
It's manually.
So, yeah. But don't do this with a big drone. Warning.
So, yes.
So I, like, how much time do I still have, Ricardo?
5 minutes.
5 minutes. Okay, I think that's, is that far with questions as well?
Yes, but you, given your situation, you can go ahead and do your final thing in the way that you like. Please go ahead.
Because I do have one final demo to show, which is not in the project itself, but it is kind of like, you know, it's kind of like the
Sure, go ahead.
big wow.
Go ahead.
I'm first going to go through the conclusions, then I'm going to end with the final demo, and hopefully we'll have a couple of more minutes for questions.
For questions, yeah. Excellent.
So just kind of to conclude, like I showed one crazy fly simulated and one real crazy fly in the real world, where we kind of like alternated between the simulated application and the real application. And that's a very important tool to have when you're doing robotics development. And it will accelerate also your development by so much. You don't want to only work on hardware for sure. When I was making this wall following node, I also alternated between simulator and the real crazy fly. And that's just the way how things have to go, not only for safety, but also for your sake as a robotics developer. There's a couple of things to consider. I simplified a lot of things in this tutorial. 40 minutes is not a lot, or 55. So there's a couple of terms that you kind of also need to know when you want to work with quadcopters and simulators. Like the sim to real gap is very important, the positioning, like how you get positioning is very important. Also, always think about enhanced safety. Crazy fly, sure, it's a bit safe, but if you have a bigger quadcopter, make sure you have an emergency button for the real thing. That will react on it no matter what. Also, kind of ROS2 project management. I started all the ROS2 nodes by myself. I did that on purpose to kind of show you what's actually going on, but you can all manage that in one big launch file. That is no problem at all. And also software in the loop is also very important. Yeah, so one final demo.
Yes, go ahead.
All right, so I just need to do a couple of changes because this is kind of outside of the project for sure.
Okay.
But we're going to be able to see RVIS, the result in RVIS. So I'm just going to change a couple of things in the server.
Okay,
I'm going to
this is
jam
real robotics developer
crazy flies
in real time working.
In the abstract, and this is also for Ricardo, new one. I said swarming.
Awesome.
So yeah, swarming is not really done with only one crazy fly, of course. So now let's pray to the demo gods.
Yeah, we are praying here.
Please pray.
Yes.
Please pray, because I'm going to do a swarm mapping.
No way. Okay.
Okay, so let's go to the. I think I should be still able to connect through the RosJect.
Yes, probably, but to only
So
one, right? Ah, no, because you are connecting to the computer, so you can control all the robots.
exactly.
Ah, awesome.
So I'm now currently starting up. I can control them from here as well. Let's also start up Arvis 2. It's a different topic, so I need to add a different map to it as well. That is called merge map. Oh, there you go. Okay, everything is still going well so far. Thank you for praying, people.
Wow.
Thank you for praying.
Yeah, we are heavily praying here.
Yes. Okay, ready for takeoff.
Let's go.
There you go. And now let's make them rotate a bit.
Awesome. Wow.
All right, maybe
Yeah.
a bit to the side, maybe a bit to the forward. So they're not controlled by wall following, but they are controlled by me at this moment. But they are collaborative and merging maps together.
Wow.
There you go.
Yeah, so the
let me
three
just,
drones doing the map at the same time.
There you go.
Awesome.
So yeah, that is was my surprise to you, Ricardo.
I had no idea. Yes, because we only went onto the first drone doing the map autonomously. That is awesome. That is awesome. So super cool.
All right, I think I'm done.
Yes. Thanks very much.
So this is definitely the last demo. I have no more. The box is empty. But in the notes, there's a couple of interesting links to like the server I used on my computer and the code I used for this project. So you can kind of refer to those. And also don't forget to follow like ROS2 tutorials of ArduPilot and Kishor. They have great stuff as well. Yeah, any questions? Is there still time for questions?
Yeah, let me ask you one question, okay? So
Yeah.
here there are several of people, and people, I don't know, you can see the conference screen, but they are applauding to you. There is a symbol for applauding, and then you are getting a lot on there.
Oh, okay.
Yeah.
Thanks a lot, guys. I'm not looking at the stream because I'm
Yes,
afraid
that's
for
understandable.
the connection. There's probably just a little bit of... but yeah, thanks a lot to you guys for listening and enduring the process of the demo effect and the conference effect.
Yeah, so much patience. Then let me ask you one question, which is the most voted one, is from Alexander Warkus that says, what sensors are on the copter?
What sensors are on the Quadcopter? Let's grab one, shall we? And make sure that it doesn't fly in my face. So the sensors currently that's on the copter itself is an IMU. So there is a gyroscope, not a magnetometer, but an accelerometer that's on the drone itself. And then you can also add decks like the multi-ranger that was doing the mapping. There's something that you can add on to the quadcopter itself. And then suddenly it's able to also detect ranges as well. This is a deck that is able to detect the light sweeps from the lighthouse positioning system. So this enables actually have the Crazyfly do onboard positioning. So that's also a sensor. We have a whole bunch of sensors, like for instance, if you don't want to set something like this up, maybe a flow deck is better for you.
Yes.
With optical flow and a range sensor. So then you can kind of have something that is able to fly by itself without a external
positioning
setup.
system.
So, yeah.
Okay. Okay, then unfortunately we don't have more time for questions. We have several here, but we have to switch to the other one. Thanks so much, Kimberly, for your excellent presentation, awesome preparation, and I apologize for all the trouble you suffered, but you reacted so awesomely. Thank you.
Yeah, I'm glad that I was able to show all the cool demos. I think that was the most important, and we got it out, so I'm happy.
He's recorded.
Yes, awesome.
He's recorded, yeah. Thank you very much, Kimberly.
All right, hey, bye everybody. Thank you for listening.
Thank you.
Yes. Thank you, Kimberly. Very nice. Guys, I want to take a quick moment to let you guys know that we apologize for the technical issues we've been having. We've been working on the background to get them solved. So please now, you should be able to refresh your browsers, log back in, if you had those issues for the people that are asking in the chat. You also might have seen a box on the chat where you can actually rate the, I think I'm having an issue here with the noise, you can rate the speaker. So please take a moment to do so.
Oh,
All right.
no, you are having problems with the mic, so no, we cannot hear you. The people cannot hear us. So, hello.
There we go. I
Okay,
think we're
right.
back.
Yes.
Good stuff. So yes, again, make sure you take a moment to rate, because at the end of the conference, we will be selecting the best speakers based on your votes.
Yes.
Definitely. Now, before the next speaker hits to the stage, let's have some fun again.
What's that?
So we're
surprise.
going to do another quiz prize right now. And how does this one work? So we're going to watch a 5-minute video about a robot product by Bitcraze. And at the end of the video, again, you will see a question related to the product. So the first person who answers correctly in the chat will win a crazy fly quadcopter like the one you saw in the presentation, plus a charging system station and a positioning system. So you may need to go to the page of the sponsor to get to the answer. So now let's watch the video, and the next speaker will be back in 5 minutes.
See you soon.
See you soon. Welcome back. So now let's see who has answered properly the question. And I can see several people are mentioning the QI deck. But, so there has been several people mentioning this, but in this case, I think I'm going to give the correct answer to Alexander Warkers because he mentioned completely the name, QI 1.2 Charger Deck. So congratulations, Alexander, you won the Crazy Fly package. Excellent. Then now let's go to the next presentation. So today, what I would like to say is that we constantly hear about humanoid robots. Humanoid robot here, humanoid robot there. Many big players, they are also entering into the field, like Tesla or Unitree. And the question that we should ask is, why are humanoid robots so important? What can humanoid robots do? And what does it take to be a robotics developer working with humanoid robots? In order to answer those questions, we have here a couple of people from the Parab Robotics company, which is a humanoid robots company with more than 20 years experience. Then Luca Marchionni and Sai Kishor, they are both members of Parab Robotics. Luca Marchionni is the CTO of Parab Robotics, and Sai Kishor is a senior robotics developer from Parab Robotics. So today we are going to ask a lot of questions. Thank you for coming, Luca and Sai.
Hi, nice to meet you, everybody.
Thanks for the invitation.
Yes, so we are very excited to have you here. Even we have some troublesome, but we have already solved. And then especially for this interview, I think that is going to be easy peasy here, especially with your experience. By the way, so your company, Parab Robotics, has 2 nominees on the ROS Awards of this year, right?
Yeah, it was a surprise, but
yeah, one is which one? Is the robot, right?
yes, the Tiago robot.
Tiago robot. And the other one is you. is the man. He's the man. So you are 2 nominees. Excellent. So we'll see that, but we cannot tell you who is the winner on both categories until the end of the conference. So far, let me ask you some questions about the company, Parab Robotics itself, because I think that the audience are interested on those humanoid robots companies. So which type of robots do you build at Parab Robotics, Luca?
At PAL, we build many different types of robots, from mobile bases up to humanoid robots. The company started more than 20 years ago. This year is 20 years old, the company. We started as a research and development project around the humanoid robots, and then the company grew, and now we have many different type of robots and services that we offer. The company is organized in different business units. Intralogistics for more industrial purposes, with Stockbot for inventory taking in retail. We have mobile bases too in this business unit. Then we have everything related to mobile manipulation. So the Tiago family of robots with 1 manipulator or 2, and even 3. And then we have the legged business unit, in which we serve mostly R&D market, universities or research center that want to start doing research or continue doing research with a commercial platform. So we offer not only the hardware, but also the software and services maintenance to keep them up with the research they want to do on legged system.
So for humanoid robots, would you say that most of the business is in research?
Yeah,
for present?
Especially for humanoid robots, most of the customers that we have, and even the customers that ask us about the possibility, even if there is a small shift in the recent year. So there are interest from great industrial companies about testing, evaluating, and assessing the potential of using for real this robot in production line, in factories, but still most of these type are related, like are pilots, are more tests in more or less real environment, but still there is a lot of work to do to deploy complex robot as a humanoid robot in a production line.
I see. And then can you tell us, just as a secret, now that nobody is listening, any robot that you are building right now?
Sure.
I mean, some of the latest ones that are about to be released or something.
Well, we are currently working on Kangaroo. It's a new bipedal platform that with a more innovative technology that we built. Everything of Kangaroo is built in-house, right from motors, motor control boards, even the design. And it's pretty innovative that in order to squat, usually every humanoid needs 3 motors to actuate. But our Kangaroo can do it with only 1 motor.
Wow.
Yeah, and also we are one of the products we are working on is Tiago Pro with the new serious elastic actuation. So you can also have the torque control. You can also have more dynamical control on the robot.
But that is a new version of Tiago, or is an upgrade of the existing one?
Yes.
An upgrade.
It's an upgrade. Plus, it's a completely new design, new electronics, and pretty much it's a better version.
It's like a version 2.0 or 3.0, something like that. Okay. And then what? Now that I'm talking to you, Sai, so what sparked your interest to work in these kinds of robots?
Well, I was always fascinated about robots from childhood. From childhood. But then once I started back in 2015, I visited PAL Robotics. I saw them, their website, their robots, it's cool. So I dropped them a couple of emails that I really wanted to visit. When I saw the Ream that day, it completely blew my mind. That's when I decided that I wanted to pursue this passion.
Nice. And how long have you been there already working?
It's been 7 years.
7 years already. Wow, awesome. And what?
This September I'll be finishing 7 years.
Awesome. And what about you, Luca? So what sparked your interest in working for developing humanoid robots?
I've been always fascinated by technology in general. Since when I was a child, watching movies about Star Wars, droids, artificial intelligence. And then when I started engineering at the faculty in Italy, I had I was lucky enough to start working in a team that participated in RoboCup. So I started learning Linux, C++ programming, and hardware, laser. There were times where SLAM was still an open problem, so we started looking at how to build a map, navigate autonomously, and I get into that world, and then I didn't come out. So,
but then in that case, it was in general sense of robotics, right? Not on humanoid robots specifically.
Yeah, it was a general robotics, mostly, let's say, computer science.
Yes.
Then I entered a few companies before joining Robotics, trying to look for my place in the world. And then when I discovered this company, Robotics, that they were doing humanoids, it was love at first sight. I started together with you as a software engineer in the navigation team. Then I started getting more involved into control, balancing for walking, motion planning, a little bit more also on the hardware side, supervising some development about actuators and so on. And now I supervise a little bit of everything about new projects, new system, new robots, trying to coordinate between the different teams that we have in the company.
Awesome. But then, in order to get into that path, so which kind of education did you follow, Sai?
Usually, it's better to have a master's degree or a PhD. And
in which?
In automatic control and robotics.
For example?
Yeah, control and robotics, basic. So it's better a bit of kinematics and dynamics, plus a good programming would help a lot, for sure. And a hands-on experience on different hardware really helps.
And in your case?
I studied engineering, control system engineering also, both a bachelor and then the master. I started a couple of PhDs, but then I dropped because I was too busy.
Too busy. Yes, I remember when you started the first one, and you were like this of work, and then you wanted to do the PhD, and it was crazy.
So no, I think engineering for sure. Then you need to have quite good math understanding, and for sure especially for Sai and me that are more related to whatever is control, actuation. Sensor calibration, you need to have a good understanding of control system. We end up at the end managing sensor and motors, and you have to make things work together. So that is a good background. And then also I think it's important to know dynamics, so a little bit of physics. At the end you have a mechanical system. It's a rigid body. you need to know about how to control this system in the world. So everything that is more defining the robot as a mathematical model, controlling it, and giving it also some simulation to validate the idea before testing it on the robot. So simulation for sure is part of our daily job.
And I would add also analyzing a bit of statistical data helps because when you do an experiment, you record a lot of statistical information. And when you look at it, you really need to know which is the root cause of your issue.
By gathering the data and then doing an analysis, applying different techniques. And do you think now that nowadays having a degree is also that important? Because you have mentioned about knowledge, but not about the degree itself. So those degrees in those times, they provided this knowledge, but now there are many other ways of. What do you think about? Do you think that having the actual degree by a specific university or entity is that important in getting a job in humanoid robots? Okay, I'm specifying in humanoid robots because it's the subject. What do you think?
I mean, the truth is that I think, I mean, at least personally, many of the things that I studied in the university, I at least use them, apply in derivatives, integrals, or and differential equation. It can be strange, but it's true that sometimes we need to have that knowledge.
Yeah.
Then I think that the university, especially for me, helped a lot building the modus operandi. So you need to reach a goal, and you need to
follow some steps.
Step by step. So there is nothing that can be done immediately. So you need to understand, okay, analyze the situation, understand what could be a possible reason for something that is not working, prepare a plan. So step by step, like an exam, no? So you have the date of the exam, but you need to study 3-6 months before to arrive to that point at least with some probability to pass the exam. And I think it's the same that I think then that type of modus operandi or let's say can be not only learned in a university. So it depends a lot also on the character, on the personality of a person, on the attitude, on the how much energy and how much interest everybody puts in what he's doing. So that is the important part. So some universities, and they are not all the same, no? So you can do engineering in one university or in another, and there is a lot of difference. So I think that especially depends on even very few, variable that you cannot control. The professor that teach you robotics, if it's a very charming person, can make you fall in love for something, and then you start. Okay, I want to be like this.
Exactly.
Or maybe a group of friends and students that you do that can also shape the way you start doing outside also the university. So I think that many factors can influence the path, and especially I think that most important that you need to figure out what you like to do. Because every career has its own difficulties and steps or obstacles to overtake. And robotics is nice because there are many problems to solve. So if you like problems, probably robotics could be a good career.
And hard problems and difficult problems.
I also say that enthusiasm is a good friend. So you should also have enthusiasm, because sometimes what you learn in the university, it's limited, and you need to have an enthusiasm to go a bit beyond sometimes. And that helps. And only a university degree is needed, as Luca pointed out. You need to know the step-by-step process, because if not, it's like you won't understand what's going on. And it's a trial and error method. At some point, you're going to achieve, but how fast you achieve is the difference.
Yes. So it's speeding up your process.
Yes.
And okay.
But it is needed.
And are you asking, when you are hiring, are you asking for a degree in the candidates in general?
It is true that the job offer will normally specify a degree in computer science or electronics or mechanics, depending on the position. But it's true that normally there is this like a requirement. Is it true?
Yes.
But it is also true that sometimes if you have comparable experience, you can have. It's not something that then, I mean, we put it in the job offer, but then we don't do screening on the curriculum based on that. So,
Never. It's just an offer, and then based on that
because I think that actually the sentence that we use normally is bachelor or master degree, whatever, or equivalent experience. So that is the sentence that normally we use for also encourage people that they don't have a specific degree to also apply if they think that they match the job description. At the end, it's more important what you are able to do than what you study.
I agree.
Exactly. Okay, I wanted to clarify this point because for the audience, this is a very difficult point. Because they are trying to decide, how to get into this, and then should I get a degree? Then with you providing this information, they can make a better informed decision about whether going to your career by doing things and working in different, starting from very low, for example, and getting this experience that you mentioned, or doing projects, or going to university, but in a good university, to a good university, and do and be very focused on that, on learning this material. So that's very clarifying. Okay, then let me see here other questions. Then what about Sai? So can you describe, as a humanoid robotics developer, so can you describe a typical day of work?
Well, typical day of work, we sit down with Luca and other colleagues, and we decide, we go through the problems that we have and how to approach it. And we try to come up with each and every solution and try to go with which is the most optimal one. And along with that, Luca, we might also have electronic issues and mechanical issues. We ask Luca because he is the CTO of the company, and he will be dealing with the other teams as well. So he is the main coordinator between all of us.
Yes, as the CTO job, exactly. So basically, let's say your 80% of your job is to be working on it, solving engineering problems, right?
Yes.
That would be it.
Yes.
This is very important for the audience because they want to know. That's why I'm asking you. So I'm going to work on, and then I'm going to be on this meeting in the morning. There's the other meeting.
No.
Then I have to coordinate these people. So I don't know. What I want to do is to solve humanoid robots. So that's what you're doing.
In that case, I'm very happy to have Luca at that point because most of the times we try to avoid unnecessary meetings. Like I see a couple of my friends having a lot of meetings than doing actual work. But usually we tend to do more work, and maybe per week we'll have 2 or 3 hours of meetings. That's it, per week.
Per week, okay. Lucky you. So cool. No, that's very cool. That's how it has to be. That has to be. And then that's awesome. This is awesome. And let me say, so how is your team structure? So do you have like a hierarchical way on your team, or you have more a flat way? How do you work together in order to solve the problems?
It is a bit hierarchical. Of course, we all report to Luca. And with Luca, we have team leaders, and the team leaders have a particular team. And it's not, sometimes the teams are already structured horizontal and vertical, so we work with per robot, and also our team is called control team, and we deal with also humanoids, mobile bases, as well as mobile manipulators. So mostly mobile manipulators and humanoids. And the mobile manipulators, we tend to, we have a separate 2-3 people group. They work especially on the mobile manipulators, and a part of our team completely works on humanoids.
Okay. Also trying to give a sense to the audience about how, if they work in a similar company, how would be their colleagues and their day-to-day basis. That's why it's important. And can you share a recent project that you have been working on a problem that you are trying to solve but still not solved? If it's not secret, something not secret, okay?
No, because we just came back from a delivery of our first kangaroo to a university in Austria.
Okay.
And it's fun because you arrive in Austria at the airport, at the duty free, and everywhere is no kangaroos in Austria. and we were delivering a robot that is called Kangaroo, so we were like very. Okay, so now we have to change this. So,
Now exactly now there is a kangaroo in Austria.
now we can say that there is a kangaroo, at least one kangaroo in Austria. Yes.
Yes, exactly. I think that this is a very good marketing for your.
Yeah, no, it was a very, let's say, this is like the first customer that bought a kangaroo robot, that is this new agile humanoid robot that we have been developing for the last almost 3 years. And it's a new, let's say, concept of actuation with really built up from scratch every component of the robot. So it's quite interesting as a as a legged platform, because it's has some unique points in terms of motion. For the legs, we pointed to everything is made with linear actuators instead of rotary actuators like traditional, let's say, robots. It's a platform that is very robust and is meant for agile locomotion, jumping, running, and also it's let's say it's very the design, we decided to keep it very rough,
Simple.
simple for having a robot that is easy to use for researchers. Because we come from the experience of having built many generations of different humanoid robots, and one of the difficulties that we have when you deliver a robot like this to a university, they need a lot of infrastructure, they need a ceiling crane, they need 2-3 people for dealing with the robot, doing experiment. If the robot falls down, it's a very a mess because can break everything. So the kangaroo is a little bit trying to reduce the entry barrier for doing research in leg and locomotion with a robot that is capable, is a human size, but for the moment is only leg and a torso, but there is also already the possibility that we are foreseeing to add arms to the robot. And the robot is quite lightweight because for the moment it's about 40 kilograms. And it's, let's say, it's easy to handle. Much easier than Talos robot, that is the other big guy that we have been selling for research in humanoid robotics.
And then this robot, for example, has a system that prevents it from falling. Because
there are several levels of safety for sure about, okay, you can still use, we normally suggest to use the crane. But there are also some features that we added on the robot that make it more robust. So all the motors of the robot, for instance, are around the waist, and we added to the robot a protective belt around this motor, so that in case of a fall, the electronics and the motor should be protected. Also in the torso, there are some flexible materials that we added that should absorb the energy of the impact without damaging the electronics, the computer, or the battery. So this is the idea. Awesome. Then many things need to be still solved, and actually this was a little bit now the end of the story. It actually is the beginning of the story. Now with the first delivery, it's just the completion of a first important milestone for us, because we have been working very hard in the last 6 months, because there is a lot of things to do in terms of control and behaviors for this type of robot. Even the simulation is complicated because this robot has many closed kinematic chains.
And then Gazebo
doesn't support them so well, so we started also looking at alternative simulators. We started improving our own simulator. We started using Mujogo. We started using Isaac Gym. We started looking at reinforcement learning for learning from scratch walking for this type of robots. And we started modeling all the small parts of this robot that when you want to model it for complete, is 76 degrees of freedom, only the legs.
Wow.
So it's like 6 times more complex than a typical 12 degrees of freedom robot. The benefit is that thanks to this closed kinematic chain, we have a very lightweight and an agile leg. The leg is minimal. You have no electronics, no motors. Everything is moved up in the torso. So it makes more easy to control using a simple model like the inverted pendulum or so on. Because
almost passive, almost a passive walker, right?
So there are, let's say, from technology point of view, is a great advancement. It's true that from control and software point of view, there are many challenges to be solved yet. But we are very, let's say, we are busy. We are happy and busy, let's say.
Okay. Yes, I can see. Wow. Well, but you put a lot of stuff there on the table, and we don't have the time to talk about this. We need 2 more hours. Okay. Let me So for the guy, I'm pretty sure that the audience there is super interested because you throw about the different simulators, the reinforcement learning for the, my God. But let me go to another question that is on the script, okay? So it's what set of programming skills, physics, mathematical skills are required for developing the Kangaroo, for example?
Well, as we mentioned earlier, you need to know the basic physics, the kinematics of the robot, Jacobians, what is a basic Jacobian at least, and you need to know a good programming skill in C++ at least, because at PAL we do 90 to 95% of our code in C++ to have the real-timeness on the robot. Because for instance, Talos and Kangaroo run at 2 kilohertz control loop frequency.
In real time?
Yeah, in real time. Along with that, some strong background in mathematics, differentiations, and also it's also good to know the new technologies that are being, like for instance, MPC, optimization techniques, because you also form a lot of optimization problems on the robot and you solve them. Either it could be hierarchical or weighted optimizations, etc.
Yeah, for this kind of robots, you are more focused on modeling and control, right? Rather than, for example, higher level skills like navigation or manipulation, right?
I mean, yes and no, because actually the good part of the software architecture that we have on the robot allow us to use a lot of software from the different robots. So already on Talos, we started doing navigation. So we have, on top of the basic, let's say, step planner that plans the step where the foot of the robot should land, we added some perception, so the robot is able to build an elevation map, identify planes or regions where the robot can put the foot, and then so define, okay, an endpoint, you want to go to that point, and the robot is able to generate a list of steps and also plan online in case that something changes, is an obstacle moves or something new gets into the scene, the robot is able to modify the step. That was already done on Talos last year, more or less. And now even the walking algorithm that we are using on Kangaroo is exactly derived from the Talos algorithm. So we changed the low level because of the different hardware, but given the benefit of using ROS control and all this, let's say, framework that allow us to abstract the hardware, we can reuse the same controllers for walking or for higher level task. So the goal of the Kangaroo project then is to leverage the same planning and perception algorithm of Talos, even going beyond that, because thanks to the lighter structure and more dynamic behavior that Kangaroo can do, basically we want to do more stuff, more dynamics. So we want to have a robot stepping on stones or maybe jumping, and so I mean the inspiration of Kangaroo, I mean, it's not very difficult to imagine, but it was we were amazed by Atlas from Boston Dynamics, and we wanted to do an electric robot able to do similar stuff. So parkour, jumping on boxes, moving on inclined surface, and be very, very agile in this sense.
Awesome. And then, so we'll put some links. Do you have videos about that? We'll put some links on the...
We have some videos.
Okay, so we'll ask you those and put some links on when this video is published, this interview.
No, actually, this year we plan to go to Roscon in Odense with the Kangaroo.
Bring it. Oh, awesome. And it's very important that you mentioned that this robot works on ROS, right?
Yeah.
On ROS to control?
Yeah.
Yep.
Oh, ROS to control in real time then.
Yep.
Right now it's with ROS1, the humanoids. But
Okay.
we are migrating them. We are expecting it in the next couple of weeks or months. Yeah.
Okay. So then for a humanoid robots company, ROS is an important skill also.
Yeah, I mean, that's the reason we are making a lot of effort in also adding new features to ROS to control along these months, so that we really wanted to have these features on the humanoids.
Okay, excellent.
And especially for us, it's important now to deliver something stable to customers. So for this reason, Sai did a lot of effort trying to push as much as possible new feature that then had to be merged in Humble and in ROS2. And we are still thinking about if moving to rolling or not, but so we have an active role, let's say, at least in the part related to ROS control. That is the critical part for us, the one dealing with motor, sensor, and the real-time controllers.
Which is the basic functioning of the robot. Without this, you don't have anything. Okay, let me switch to another topic. It's about the future, so or the current trends. So your robot seems kind of very futuristic. I mean, like the last in the technologies in order to have modern humanoid robot that is, as you mentioned, is a lot easier to manage, but also more able to move into real environments, which was one of the limitations of the past humanoid robot. So which tendencies, which trends do you see in humanoid robots? It's going into the direction that you have mentioned, or is something else that is in the future people are working already in those technologies?
I mean, the trend, I mean, now there is a lot of interest in humanoid robotics, no?
Why?
I mean, because there is a lot of money that is being injected in many companies.
Why?
And startup. Probably because of Elon Musk effect.
Okay. Okay, yeah, you said something interesting. Yeah, because I mean, so I worked with him for many years already, so I know about that. And then we were doing humanoid robots, and then
nobody cared about
nobody cared about it. And everybody said that was stupid. For what do you want a humanoid robot when you can have, you don't need a humanoid robot, you can have the Roomba cleaning and that.
Special robot for each application.
For each application, exactly.
Now everybody is saying general purpose.
robot.
General purpose. Okay, so now you come and so that's stupid.
No, I mean, I know. I think that from one side there is all the let's say what the artificial intelligence hype awake in like now everybody thinks that the artificial intelligence is going to conquer the world.
Yes. Yes.
So that gives some more confidence that an artificial intelligence can exploit a humanoid robot at its maximum performance.
Yes.
So I think that I mean, from one side, that for sure helps. I mean, if now artificial intelligence is able to replace, I don't know, many automation jobs, probably also the fantasy about having a robot with the shape of a human, able to use the human tools in a human environment and so on, it's more, I don't know,
appealing, right?
Yeah, more okay. Maybe they are not so crazy.
So exactly, so crazy idea. Okay.
And then I mean, when I think when Elon Musk start saying something, everybody, I don't know.
Is listening and saying, "Oh, that's very so clever, guy. Nobody thought about that before you." Yeah. So one final question. We still have here, but we are running out of time. So let me ask you one. What do you think about the large language models and its effect in robotics development?
Well, it's not going to solve. It's only the language model at the end of the day. So maybe what it's going to replace is the state machines and the behavior trees that we inject in between, the high-level behaviors. It's going to replace that part, because before we have the speech detection and then understanding and natural language processing, and then understanding it to formulate the problem,
to understand the context.
Exactly. So that's a huge part. I mean, as I said, it's many steps and it's a huge computational part as well. And LLMs are pretty simple. So it's like, okay, get me something. So it understands and it can formulate these things. It helps us to avoid this programming part.
Yeah.
And for developers?
For developers, for sure. I mean, there are Copilot, and
yes,
there are very many, even the ChatGPT integrations into the IDEs. It does hamper the performance of the developers. I would say yes.
So you are using it?
Yes, we do.
He's using it.
Yeah, no, we decided to, as a company.
Okay.
So we have. No, we decided. I mean,
no, because we are doing a test phase right now, and also what you need to understand how to use it. It's just a tool.
Yes,
it's not going to replace anything.
Yes, that's
so
right.
So if you know how to use it as a tool, it's going to amplify your performance at least 50%.
Yes,
but if you're asking it to solve everything, that's not the way it
yes, is. Okay. Very good point. Very well stated. Yes, okay. Okay, then, guys, thank you very much for coming here and sharing so much knowledge and so much advice for the audience. Thank you very much. And now it's time for the audience to ask questions to Sai and Luca. So you know that there is a Q&A tab beside the chat where you can put your questions or ask the questions, or both the questions that have been asked there. And I will move those questions to him. So we have one from, Sebastian Castro. Hello, Sebastian. Sebastian, yeah, old friend. And also start to warm up because you are about to come to the stage also. So Sebastian is one of the most voted here. He says, it seems that robots have very few public educational resources compared to other types of robots, like wheel, manipulators, etc. Do you have any recommendations for where to learn some of the specific for kinematics, dynamics, planning, control for such robots that make contact with the environment to locomote?
It's true that it's more difficult now.
Yeah, it is pretty difficult. I mean, there are pretty particular courses in Coursera about the kinematics and dynamics, and also some model predictive control, but they're not centered around humanoids. That's true.
I mean, there is, I think, I remember there is in Rusted Drake a course about dynamic, MPC, and Drake, basically.
Yes.
That was quite good. And also, I think from Carnegie Mellon University, there is a quite good curricula of classes about, they build it, I think, from the experience on DRC with the Atlas. So from QPs to dynamics to simulation, it was quite good. And then also, I mean, I remember that when I started with Davide in PAL, he also passed me a very good Japanese website in which there were basically all the literature about walking. Wow. And also some tutorials and example of code to run in MATLAB or C++ for at least for the walking as well.
Yeah. And also there are papers from Kajita.
Yes.
And that helps a lot. I mean, that's the basic starting point.
I remember to have actually bought, there is a nice book from Kajita.
Yes.
That was only published in Japan for many years. And then there is a French edition.
I remember that you have this one.
I bought it. Yeah. So there is this I think it's there are very few books about legged robots, and this one from Kajita is very nice because it goes from the kinematics up to the motion planning.
Yes.
Wow. Nice. Awesome. But also a small business here for the construct. Okay. So do we have time for one more question? Okay. Then let me go to the next most voted. Is Hussein Emre that says, what is the benefit of using humanoid robots? For example, a wheel ground vehicle can be used for many applications without volunteer uses. Of course, there is a niche advantages, but it's cost-effective solution.
I mean, in my point of view, you should be curious to explore. I mean, even the wheel robot that we are talking about right now, a few years back, we never thought it is needed to solve it, because the human cost at that point of time is cheaper. In that part, for now, when we explore the options and when we are able to solve the problem because of the curiosity, then maybe it can get cheaper or something like that.
Okay. And what do you think?
It's true that wheels can work most of the time. Yeah. The problem is when you have stairs, when you have cables around, when you have
real environment.
Yeah, so
it's for limit in real situations. It's very limited.
No, and also for wheel, it needs to be pretty structured.
And
yes,
then there is also then maybe it's too simplistic, but there is always the footprint, no? So 2 feet of a robot are much smaller than 4, 2, 3, whatever wheels a robot can have.
Exactly, that's true.
So in terms of, let's say, space used for balancing, for sure the bipedal architecture is the most effective. Then it is true that it's most complicated. It's more complicated. It's more expensive at the moment compared to 2 wheels. 2 legs are 10 times more expensive. But I think that this also is gonna decrease the difference
as we move. Yes, exactly. Okay, then I think that we have to finish. Do we have time for? Okay, one more. Let's go. One more. Do you have time? Yes. Okay. Then Jacomina says, Johanna says, any advice on how to get to know into the humanoid robotics field? How to get known into the humanoid robotics field? What would you be looking for when hiring someone?
experience with hardware, that also for sure helps, because it's, very important to understand the limitation or the difficulties to, calibration or sensors, and then also I think, programming for sure. That is basic, experience, good programming skills, and especially experience with physics simulators, I would say.
Yes.
So.
And now that you mentioned the programming skills, let me enlarge a little bit the question. So what do you think about Rust language?
I started looking at it from a little bit far. It seems interesting. I don't know how fast it's gonna spread into the community. The promises are very good, no? Something that a compilation time, it basically solve all the problems that we have been having with C++ for many years.
Yes.
But it's true that I don't know. It's always a matter at the end of how many libraries, how easy it is to integrate. So it's that then the difficulties are not only learning a new program.
A new program, yeah.
It's how many libraries I can use in Rust today.
Uh-huh.
How can I can mix C++ and Rust? What's the right language for each specific problem?
As a company, we have to be practical. At the end of
Yes,
the day.
exactly. Yeah, I didn't think about that, but that is true. That is a problem that is lacking. Some, for example, even in Rust 2, not everything is supported in Rust 2 with Rust.
Yes.
So just in case that you want to know more, we have a talk about Rust 2 with Rust later today in the conference. So, and you are invited, of course.
Thank you.
You are VIP. So, okay. So that's it. Thank you very much, Sai and Luca. Thank you very much. And now, please take a moment. It's going to appear it's going to appear on the chat form where you can vote for the experience with Luca and Sai. And remember that we will have final, at the end of the conference, we will select the best speakers of the conference. So vote and rate this presentation. Thank you very much. And while in the meantime that Luca and Sai, they go, so we are going to do something else here here. So Rodrigo, what do we have here? What is next?
All right, everyone. We've had an amazing session so far. I hope you're all enjoying it and finding it insightful. Thank you very much to our guests for coming to speak with Ricardo today. And I hope you're really finding it, enjoying it, and insightful.
So now let's have some time to take a short break. So we will have a 15-minute coffee break now.
But wait, this isn't just any ordinary break.
Huh?
Why is
What
that?
Oh,
We're gonna have an exciting robot contest, which is the Limo Challenge.
Wow.
All right?
yes. Okay. The Limo Pro robot is a ROS2 mobile robot platform that integrates NVIDIA Ori Nano alongside a LiDAR, an IMU, and a depth camera. Limo Pro has 4 modes of locomotion: differential drive, Ackerman, omnidirectional, and track-based. All these features make Limo the perfect robot for learning and teaching robotics with ROS. You can even add a robot arm and study autonomous mobile manipulators for a small price. During the Robotics Developers Day, you can find a big discount buying one right now on the button that appears at the bottom right side of the screen. Buy one now and get a 20% discount.
All right, guys. Here is how the challenge works. First, we're gonna share a link with you of a ROS project through a link that we're gonna share through the chat. So let me do that right now. Okay. So in the chat, you should be seeing a link that I posted, Rodrigo Gonzalez did, and click on the link of that chat. You guys have to be paying attention for this. And this will get you a copy of the project that will allow you to participate in the contest. Once you have copied it, press the run button on the top right. this will open the project. After opening the project, you will see the rules of the challenge open automatically. What you need to do is follow the instructions and solve the challenge at any time during the conference. The challenge is very easy. Move the limo robot from the start location to the go location and use the robot camera to take a picture of the wall in front of the end location. So if we scroll down a little bit here in the screen, we're going to see some pictures. There you go. So that's the environment. This robot starts at the bottom there, and the start location has to go up to the go location. Of course, avoiding the walls, not crashing into anything. You can use the simulation that it's provided in there to develop it. And once you have solved the project, send us an email with a link to your project to info@theconstruct.ai. Again, that is info@theconstruct.ai. This is also in the instructions you'll see. And the subject has to be, in all caps, limo challenge. That is limo challenge. And out of all of these projects that you guys will send, we're going to randomly pick one to actually test it on the real limo here, on the real environment that we have in here. And if the code works on the real robot, then you win the robot.
All right, so take the time to refresh yourself and enjoy the robot contest. We will see you be back in here in 15 minutes.
And let the robot games begin.
back, everyone. We hope you had a nice break and enjoyed the fun doing the robot contest. If you haven't finished yet, it will be okay. You can keep trying. And remember to send us the link to your project once finished.
Yes, you have all day, all conference to do this. And the next presentation that we have today will be another hands-on learning session. So that means that, again, you're going to have to open a robot project so you can practice with the speaker. So you can click on the Open ROScheck button besides the name of the speaker right there.
Yeah, so like yeah.
And again, we've been, so if your project is loading, don't worry, just wait. It will open eventually.
So while you are getting your project set up, we want to highlight of the fantastic social media posts you've shared. So yeah.
Nice, with a nice little projector there.
Wait. Those are the old ones.
Ah, these
Those
are
are the
old.
old ones. I
are
remember them from last year. So do we have the new ones? So let's see. In a second, they are going to appear. The new ones that people have shared
Let's see
along
your
the
conference
conference.
desk set up.
These I don't remember. This one is okay. Not yet. No. Okay. Yeah. Okay.
All right, maybe no posts yet, but remember to post them on social media so you can get one of our swag boxes here with just post it on social media under the hashtag RoboticsDevDay.
So here we have the first one that is from this year.
Very nice.
Awesome.
Nice.
Well, nice little coffee.
Okay, good. Yeah, this got me. So this is the coffee.
Yeah, there you go. To be able to handle. Nice.
That's
More
the best.
screens, the better. Yeah.
Yes.
You can practice and watch the stream. That's good.
So yeah, remember to post it under the hashtag RoboticsDevDay.
Yes, I also like it. Okay, so we have the first round of which one. So what do you think? Right.
I mean, I like the one with the coffee, to be honest.
Me too.
Just because it's simple and to
Which
the
one
point.
do you like? Which one?
The first one and the coffee one.
Okay, the first one on the coffee. Then I think.
So we're gonna pick the one with the coffee mug,
Yeah,
I
of
guess.
course. I mean, coffee always wins.
We all
I
mentioned
know,
it.
I know. Coffee always wins.
Again, this is at our discretion as well.
Yes.
So we pick. So congratulations to the guy with the mug. I couldn't read your name, but you're the winner.
Yes, our team will contact you for the details. Excellent. So now it is time to dive into our hands-on session. In this session, we are going to learn how to program robots using the Rust language. Rust has been defined as the language for robotics developers, with the efficiency of C++, but without the hassle of having to keep every small detail during the compilation. So our next speaker is going to teach us the basics of programming ROS with Rust. Júlia Marsal. She is a robotics developer and also is a robotics consultant. Today, Júlia will guide us through programming ROS2 with Rust. Welcome to the conference, Júlia.
Hello, can you hear me?
Yes, we cannot see you. Ah, there it is. There she is. How are you doing, Júlia?
Fine, thanks for the introduction. Thanks for inviting me to this learning session. And congratulations for the overall event. That it's awesome.
Thank you very much.
Excellent speakers that we have today, and I think that's awesome. Congratulations to you.
Thank you, and you are part of it. So thanks a lot, Júlia. Thank you. Then, are you ready for your presentation?
Yes.
Then let's go.
Okay, let's go. Welcome everyone. Welcome to the ROS2 programming ROS2 with Rust session, skill learning session. As you might know, Rust it's on the date, it's up to date. So what is Rust? Rust is a language that empowers everyone to build reliable code and efficient code by default. And ROS2, as lots of you know, is a system framework for robots. And now ROS contains the possibility to be define design with Rust. So what we are gonna do with this project, what we are gonna learn is how to develop Rust nodes with a real robotics applications. How we're gonna do that? So first, we're gonna see what is and why we're gonna use Rust. Then how to install Rust with Rust 2 if you want to try in your own computers. After, we're going to start to see how to move a robot with Rust 2 and Rust, so how to get our hands deep on a real application. To do this, we're going to create first a Rust package. Then we're going to learn some basic Rust programming tips. After that, we're going to see how to create a Rust subscriber, then a Rust publisher, and then how to create a node that contains a subscriber and a publisher at the same node. It seems easy, but it's not as we think in Rust. Then we're going to see some feature works and the Q&A session. So, who am I? My name is Júlia Marsal, and I am an industrial engineer with a master's degree in robotics. When I started and I looked at what to study, I didn't see anything about robotics. So why my first step was doing like an industrial engineer degree. After that, I saw that my role in life was to be a robotics engineer. So what I did is a master degree that I really encourage you to do it if you are like thinking about it. And where I really learned a lot of things, I learned a lot of Rust that I really loved it. And until now, what I've been doing is I've been in different universities, developing some projects and also some companies, developing some custom robotics applications, mostly in Rust. So this year I had the opportunity to start my own like brand that is called JM Robotics. And what I'm doing now is I'm robotics engineer consultant developing software for DTE. DTE is a company, it's a robotics company. It's located in Iceland. And what this company does, it produces applications for the metal of the future, robotics applications. And in addition, few times I've helped students teaching robotics and also for different universities and companies on demand, which I really, really love it. It's one of my hobbies. So please don't hesitate to contact me if there is anything further I can help you. And this is my LinkedIn profile. So what is why Rust? Maybe because it's becoming famous? No, that's not. Rust is a system programming language that it has designed for performance. By default, the way Rust has been designed is that when you are developing code, you are thinking about performance, safety, and concurrency. So it was developed originally by Mozilla in 2006, but now it's maintained by the Rust Foundation, which contains some open source parts. So the main characteristics or feature of Rust are it has a really good tooling where it's easy to work with Rust because the tooling that it has is a really good develop. And there's also the error management. It has its own way to manage error, but I think that you will love it. You're gonna see in some time. Concurrency, it allows you to execute some part of the code independently or in a concurrent way. It's designed thinking in memory safety. So when you are developing, you are thinking in memory. Type safety is a type safety code. The community and the ecosystem, it's really high. And there is lots of people. And also it is really easy to ask in the community if you need any help. Documentation and learning resources, it has its own website, and I think that I encourage you to look through it because it contains its own book, and I think that it's really, really, really good, and I encourage you to look through it. So Rust 2, by default, when you install Rust 2, it doesn't contains the Rust package. So the only way you to install the Rust 2 package, the main one, now it's using the repo. So you have to clone the repo and then install the package, okay, with a calcing build, and it's gonna like do its magic. So also it contains a Docker file if you don't want to install it. I think that you need the version of Humble 20.04. But if not, it also contains a Docker file. So I really encourage you to go to this website, look through it. It contains indications how to install it. And also it contains a lot of examples that you can also look through it if you want. So what we are gonna do here, we're gonna move a robot with Rust 2 and Rust. Which robot? here you have a simulation, okay, that you can open it. This is a awesome simulation. It has a grocery store, I think, but I'm not sure. Go, okay, if it allows me. Okay, so I'm gonna. So here, if we go to here, we have our friend that is Untitled Robot 3. And here we are gonna work with this simulation and with this robot, the Untitled 3, that is here. So if we go again, we can open our notebook and also our terminal. I hope that you have finished the overall build of the all the packages. And as I told before, there is the packages has been previously downloaded, clone that this repository, and you can find it here. Okay, so it's here the packages. So how to create a Rust ROS package? Okay, in Rust the cargo it's the package is the Rust package manager. So every time we want to build, we need to use the cargo word, okay, to create a new package, cargo new, and there are different kind of shortcuts that we can also use it. And the crate itself is the name that Rust is the name of the packages of the Rust. So crates, it's package in Rust, okay? So there is a website, it's this one that you can enter, and you can see the overall open source packages or crates in this case that Rust contains, okay? Not all Rust packages can be found, well, it's here, you cannot find it, but the main one that is the Rust2 client library for Rust exists. And we are gonna use this crate as the one that Rust contains by default. So we're going to install and get it by Rust, not by Rust2. So we are going to use this one. So what we're going to do, first, we're going to create a new crate, okay, new Rust package. We're going to open a terminal, okay. So here, what we have to do is this. First of all, go to the source file folder from Rust2 and create a new Rust package. So enter, and then I have a new package, okay, here, that it's called Wandering Behavior Rust. What does this package contains? This package, if I go inside of the package, okay, contains the cargo.tone file. This file is similar to the CMake list as in C++. So it's the file that contains all the dependencies, metadata, and compiler settings. Okay, and if I go inside of the RC, I have a main.rs file that it's created by default, and it contains some program that by default Rust does. Okay, and it should print hello world. Okay, so we have seen what we have inside of the crate after created one. But now we need the package. Okay, we need to create a package. Why we need to create a package? Because we have some packages that is in Rust side, and we want to create a cargo crate. Okay, and we want to link between Rust side and our Rust package. So that's why we have to create a new file. And it is gonna call the package, as we may know from Rust. Okay. So here I have my package, and I'm gonna copy this and paste it here. Okay, I'm creating a package that is called Wandering Behavior Rust, the same name as our crate, and the description and the dependency, and also the amen cargo. The amen cargo, what it's gonna do is to make the link between Rust2 and our package. Okay, when you are building. Okay, so what we can do now is compile this package and then compile it. Okay, it's gonna build the package that we've just done. And then we have to install, because it's a new package, so we have to source it. Okay. So Rust. Rust, the way that they have think about by default is a language that by default, when you are designing it, you are thinking about memory without knowing it. Okay. So this is the basic Rust programming tips. Okay. We are gonna see this through the examples that we're gonna see now. So you can see how to create a node, how to create a subscriber, how to create a publisher, the spinner. Okay. So, how to create a Rust scan subscriber. What we're gonna do now? We're gonna open again the terminal. And we're gonna connect with the current robot that we have here. Okay. And we're gonna see which topics this robot does it have. So we have these overall topics. So the CMD bell topic is the topic where we are gonna talk, and what we're gonna do is like command the robot around the simulation. And also we're gonna talk with the scan topic in order to get data from the scan, the LiDAR. This is a LiDAR. Okay, so the LiDAR, what it does, it detects in which distance, in each angle, it has some object. So first of all, what we are gonna do is to create a subscriber to the scan topic. Okay, how we're gonna do that? Yes. First, what we're gonna do is to create or change the name of this file. Rename. And this is not the right one. You have to use this one. Okay. You have to change the name. Okay. And copy this overall code and paste it. So what we have here? Here we are importing some dependencies from other crates from Rust. Okay. Standard environmental crate or package. Anyhow, that contains the error and also the result crates, which you can see that before we have seen that it has its own way to handle errors. So this is like how the function returns success. If it's success, it's gonna return this. If it's an error, it's gonna return this. So error handling, it's a bit different that we are used to it, but I think that it's awesome because we can define its own custom errors. So this is the main function that we are going to execute, and this is what the type is going to return this function. So context is like the variable that which like interacts between the other nodes and shares states and data from other nodes with the current node. The node, we are going to create a Rust node, passing through reference the context, and then this is the name of the topic. Sorry, the name of the node. Okay, so this is how we create a node. RCS is what we have seen before. It's the Rust client library for Rust. And here you can see what I said before, that when we are developing, we are thinking about the memory and the efficiency. So by default, Rust variables are constants. So if you don't want to change, you don't have to do anything. But if you want to be mutable, you have to put mute in the front, okay, in order to the variable to be mutable. So this is an unsigned size, and in this case, it's equal to 0. This is a subscription. We're going to create the subscription. So the same node, we are using the function create subscription. And this is the type of the message that we are subscribing to. This is a laser scan message. That this message, it comes from Rust 2, okay? Not from a crate from Rust. So the scan is the name of the topic that we are subscribing to. This is the quality of services that is, we are using the default one. What moves does is converts a reference to and gets its value. So yeah, we're getting the value from a reference. So here is the message that we're getting info from the scan topic. And here is the type of the message. As we have seen before, we are increasing the number of message every time we get a callback. And this is, we are printing some properties from this message, okay? This question mark, what it does is, if this function is success, it will return what the function itself returns. But if it fails, what it's gonna do is propagate until main an error, okay? And then spin is, we need to call it in order to call the callbacks. And here we are mapping the errors depending on its type, okay? So now we have the code, we have the main, we have the node, but we have to define the dependencies of this node. So first we have to tell to the package and the ROS2 that we need some package that there is in ROS2. So we have to add a dependency in the package. Okay. After that, we also have to say to the crate itself that it is one package that it's called sensor message that is needed. So we are going to the cargo tool and saying, okay, you need this message. And also we need to tell where is the file that it has to compile and create the binding. So we have to tell to the crate where to find the file and compiling it after or whenever you want to build it. In order you to know how to add crates inside of this crate, there is another way if the crate exists inside of Rust that you can make cargo add, okay? And then you have to go to the package or crate and then add it, okay? It's adding it. This is that it's like telling that the sensor message doesn't exist because it doesn't exist in the crates. And then we have to add the RCLRS that we are gonna get it from also from the crates that Rust contains. Okay. So after that, we've got a package and we've got a node and we've got a subscription to a topic, to the scan topic. So what we're gonna do is to build the package using ROS2 call build dependency. Okay. So we are going building Rust package with using ROS2 tools. Okay. So I'm gonna continue because it's gonna take a while. After this, what we're gonna do is to execute it and see what we get from this node and what we get from this subscriber. And the next point will be to create a Rust publisher. So what we're gonna do now is to publish to the CMD bell topic and make the robot move around the simulation. So just finished. I'm gonna source it first, and then I am gonna execute it. So I'm running it. Okay, so what I'm doing, I'm getting its info from the robot, and I'm getting the distance from the range in a specific angle from the robot. This is the minimum angle and the angle max from the robot from the LiDAR. Okay. So next point, we're gonna command the robot with a Rust node. So we're gonna create another file. Okay, this file is gonna call cmd bell publisher. Okay, we're gonna copy this overall code. So here we have almost the same as before. We have the standard environment as pack or crate as before. We have the error, we have the result as before, and we are like calling to the twist message because we are gonna use it to publish to the CMD bell topic. So first, the same as before, create the context, pass by reference, creating a new node. And then when we have the node, we're going to create the publisher, different function. We are passing the type of the message. This time it's going to be a twist. This is the name of the topic that we are going to talk with, and the quality of services default. We are using the default one. So here, as you can see, we have the CMDBell message. That is the message that we are going to publish to the robot, and we are going to creating a default one, like just initializing it. We are creating mutable because we want to change it. The idea of this code is to create a pendulum movement, okay? A movement that it changes. In each publisher, you change the velocity in order to not let the robot crash with a wall, just to have the robot controlled. So here is the velocity. It's a value that we are going to change. And this is the message that we are going to publish. So we have a loop, and on every loop, what we do is changing the message type, and changing the message, and changing the velocity. Okay, so with the velocity, it's less than 0.2 meters. We are like putting it positive in order to go to the stripe, okay, to the front. And this is changing the velocity in each loop, depending if it's not this value, it's gonna change it. Every loop, we publish the message, and then we sleep. Okay, this is the thread that puts the thread to sleep, 500 millis. Okay, as before, if everything works as expected and there is no error, it's gonna return awk. Okay, or it's gonna return awk always, this kind. Okay. So that's it. In order to also to define the geometry message that the CMDBell topic needs, we have to add also in the cargo.tolm in order to tell that we are gonna use it. Okay. And what we have to do also is to create the executable. Okay. Also, we need to talk with those two packages in order to tell that we need this kind of package. So we need to change it in the package itself. Okay. And then we are ready to build everything. And then let's try to move it. Open the Gazebo. Open the Gazebo. Okay. And let's move this. Okay, let's see. The robot goes to the front and then decreases the velocity, goes to the back, decreases velocity. So it's moving. We are able to move a robot, changing the velocity from the robot. Okay. So now what we have, subscriber to the LiDAR and publisher to the CMDBell. So what we are gonna do now is to change the subscriber to make a note that it's gonna do the obstacle avoidance. Okay, so if the LiDAR detects some object, like now, it's gonna try to avoid the object, changing the velocity in the other direction. I highly recommend you to reload, okay, because in the next node, we're gonna use it, and to stop it, the simulation. It's this one. Okay. So why I think that it's so important to you to see how to integrate two nodes or two kind of topics in the same file. It's because in Rust, as Rust is a language that it has been designed. When you are programming the language itself, you are designing the code in the best way in regarding memory. So sometimes they're not. We have to think about how to do the things in the best way. So if we look through to this code, what we're gonna do is an obstacle avoidance. Okay, so we're gonna copy this code first, creating a obstacle avoidance file. Okay, so let's create a new file and copy this. Okay, so let's copy this code and paste it here. Okay, so what's the difference in this code? Why it's so tricky? Um, First, what we have to do is to add well, the same variable as before and the arg. The arg create, what it does, it it shares the ownership of the data between multiple threads. As we are gonna publish and we are gonna subscribe, so they need to share data. So we need the arg create in order to like share the data. Okay, and we need mutex in order to know if this data is logged or it is used by other threads. Okay, so yeah, same message as before, type of message, same message as before, and here is the, well, the same types as before. Okay, here what we have here is here in Rust, classes doesn't exist. Okay, what it exists is the struct. Okay, so in Rust you are able to define and implement structs. Okay, so this is a definition of the struct. Okay, this struct, it is called obstacle avoidance, and this is a property of the struct that's going to be the subscription, other property that is going to be the publication, and other property that it's going to be the twist message. Okay, that this twist message is going to be shared between the publisher and the subscriber. So here we'll create an arg, an object that shares the memory, sorry, shares the data, and of type _cat. We're going to create a subscription, and here we're going to create the publisher, which contains, or which is based on this type. So here is the twist message. That is the message that we're going to share between the subscriber and the publisher. And this, well, we have seen this. So we're going to do now is to implement this struct. So we're going to implement the functions of this struct. So the new is, it's like in the C++, we have the constructors. So the new is a constructor. Okay. So in this case, this constructor has a node that we have to pass by reference. And what this struct returns is self, the object itself that is going to have these properties. And also what it have is this is an error that it has been defined in the Rust client library. So you can see that the errors can be, you can create over your errors if you need it. So what we're gonna do, we're gonna create the message that we are gonna share, and we are gonna publish as an object. When we are gonna return it. After, yeah, this is how it does. We're creating a new share object, and this, we need to create a mutex of this object because we need to know if this object it's used by other thread or not, and the type of this like message is a twist. Okay, we are creating a publisher, so it's the same as before. We create a publisher, of type twist. It's the same as before. Maybe I can do it bigger. Okay, so yeah, it's better. Same quality by default. And then what we have to do is to create a clone message. Okay, why we have to create this clone message? Because there is something deep in Rust that this object needs to be returnable. Okay, because it is like when you return the object, you need to return it. So you cannot, like, it's kind of ownership, but you cannot like use it. You cannot like change it inside of here. So what we have to do is to create a clone. Okay, so you have to create a clone of the message to be able to lock it inside of this subscriber that we are gonna do it. So we are passing for the reference the twist message, and we are creating a clone of this message. Here we're creating the subscription, the type of the message, the scan is the name of the topic, the quality of service is the default one, move, we're passing by value, this is the type of the message that we are changing. And here, what we get is the different distance in each, like in each 90 degrees. So this is the 0 degree from the LiDAR, this is 90, 100, 270. We are printing this distance that we are getting from the scan topic. And here we are changing the velocity depending on the distance. So we are able to make the obstacle avoidance depending on the distance that we get in each angle, okay, that we have seen it here. So if in the front I have some object less than 0.5 meters, I am gonna go back the linear velocity in x, and then I'm gonna turn a little, okay? In the right, I'm gonna turn a little to the front and then spin, okay? So depending on the distance that I get in each quarter, I have a different behavior, okay? And if everything works as expected, I only go straight, okay, with this velocity that it's always in meters seconds. So it's in the international system. So if everything works as expected, here I have this question mark that also says if there is any error, this error in this subscription, it is gonna propagate to the new. So it's gonna return an error. If it's not, it returns what this function returns, that it's gonna be, in this case, I don't know, but I think that it's nothing. Okay, so it's gonna go to the next step. If everything was as expected, we return an awk. Awk, it's an object, or it's a type of object of Rust. And we always return an awk, and this is the payload that we want to get, the self, okay? Yeah, the awk, it's always this, more or less is what it has here. And we return the self because it's okay, so we return the self. Okay, so we have another function that is a publish function. So what will pass the object by reference, the same object that we are working, and here is the message that I am getting. Okay, yeah, I am locking it, and I am getting the message. Then wrap means if everything works okay, it's gonna return the payload. But if there is some error, what it's gonna do is crash the program. Okay, with what unwrap does.
Júlia,
So
5
here,
minutes.
okay. So then, yeah, we make the publisher. Okay, we pass through by reference the this message, and we publish it. And then the main function is the main code. So we return a result, and if it's okay, it returns nothing. If it's an error, returns an error. So the context, same as before, node same as before, name of the node, and yeah, we are passing through the node, okay, by reference, as we have defined in the new function, okay, here. And yeah, it's a while. So every loop we publish the message because we can only call the function that we have here. We don't need to create a specific stuff, so we can call it. And then we spin once because we have a loop. We pass the node, and then we spin, and we have a duration of 500 millis to give some time. And then we sleep the publisher. So in order to be a little slow. And then, as we have defined here, the result, we return OK. Okay, we are going to return OK. So that's it. If it fails, it's going to fail. So it's going to like return error. Okay, it's going to propagate an error. Okay, just to finish, in this case, as we have imported everything before, we just only have to create the executable. So we have to go in cargo tool, create the executable, okay? And then we are ready to build it. Okay. And then we just can run it. Let's see what it does. First, open the simulation in case. Okay, it's gonna avoid it. Yeah, it's avoiding. It's a kind of simple explorer. So he's gonna go around the simulation. Maybe it's gonna crash here because the LiDAR cannot detect this. No. Okay, that's it. That's it. You have an example how to create a publish and a subscribe in the same node. That for you, it's really awesome. So feature work. You are now prepared to build nodes in Rust. To further enhance your proficiency, I recommend you reviewing the following courses. Yeah, it crashes. So let's stop it.
Excellent. Júlia, thank you very much. Thank you very much.
Here you have some documentation if you want to look through it. I really encourage you to look through the Rust documentation, and also to look through these courses. Thank you so much, The Construct, for inviting me and for your time and for your assistance.
It's our pleasure, of course. So thanks to you, we have an introduction to Rust for Rust too, which is something that is lacking in the whole world. So thank you very much. Then let's go for the questions. Okay, are you ready?
You're welcome. Yeah.
Yes. So for the audience, you can put the questions for Júlia on the questions and answer tab that is on the chat, or vote for the ones that are already there. And I will be asking the questions that are most voted to her. Then let me, in the meantime, okay, well, I have one here, but here there is other already some questions. So it says, would you say that the Rust client actively is maintained to a degree that it can be used in production?
Yes. If you look through the Crates website, there have been a lot of releases of this package. So I think that it has really improved it, and I think that it can be used in production because it is the main node and it has been developed a lot. So I think so.
Okay, and also there is a team, right, developing behind that are in charge of improving and maintaining the Rust packages for Rust.
Yes, that's it.
Okay, then what can you say about performance? So that's a question from Sachin Kumar that says, how is the performance of Rust compared to C++ and Python?
Okay, it's a really good question. I've looked about different people that has done some performance tests, and the conclusion always was that Rust it's a really good regarding performance, and but I think that if you are a really good C++ programmer, you could know how to improve the overall code to be
more
to be
efficient.
the best in. Yeah, exactly. But Rust by default is what I love. It is by default the curve of education as a student at the beginning may be difficult if you're not a programmer or have a software programmer or have not software programmer background. So, but I really encourage you because by default, Rust teach you how to program regarding efficiency, memory safety, and that's why I
So
think that
at the same
by
time that you are,
default it's defined.
yeah, so at the same time that you are learning the language, you are learning how to do it properly, how to use it properly.
Exactly, that's it. And you're learning more regarding software engineering. Yeah, that's it.
Okay, interesting. So did you know that the Open RMF framework, which is the fleet management system for robotics, which is made by the Rust team, then that this is being changed into Rust, is migrating from C++ into Rust. Did you know that?
Yes, I know that. I every day talk with lots of things, and lots of people are thinking about migrating to Rust because my point of view as a robotics engineer is that it contains really good things. Maybe they have studied about different kind of languages, and in Rust they have picked the good of every language. So in Rust, you can like define smart pointers. You can define, for example, the strings that Python contains. That it's really nice to handle strings, so Rust contains it. So this is my point of view, that people loves it because it contains the more or less the best of each language.
Of both worlds, of all worlds.
I think so.
Okay.
Yeah.
Okay. Interesting. And then what I wanted to ask you? Yes, because before you, we were interviewing Luca Marchionni and Sai Kishor from Parab Robotics, and they were mentioning about one of the possible drawbacks of Rust for being used into robotics, and it's about the how many libraries do exist that can be interfaced with Rust for robotics. I mean, so what do you know about that? If there exist
Okay.
many libraries that can be used, because in Python we have everything. So for processing images, we have this. For computing trajectories, we have this. Matrices. What do you know about the available set of libraries for Rust?
What I can say that the Rust community is increasing and it has a really good developers. And I have seen, if you look through the crates, for example, the standard message exists in the crate, but that has not been approved yet. So people are designing code to Rust. So maybe it's not delivered and it's not available now, but it's gonna be, I don't know, now or in the next few months, but it's gonna be. They are working on it. So they are people who are developing it.
Okay. So yes, it is work in progress, and then there is progress,
Yes.
which is important.
Yes.
Which is important. And then what about which things are not supported now in Rust 2 with Rust?
What you say not supported, I would say
Officially, let's say.
officially with the crates okay, if you download the package and you build it, you go to the GitHub and download the repository, you can build and you have lots of basic packages, and not as basic but that you can use from Rust. But inside of the crates, as far as I can see, the standard message are not included yet, but it's included but not accepted, so they are working on it. The geometry message also. So you can work with Rust now with the package itself, with the Rust packages, but I don't exactly know which are not exist. But I think that you can program with Rust now, but using the Rust packages downloaded by the GitHub repo. Yeah.
Okay, I have a question here from Rodrigo, that he says, I've never worked with Rust, but the one time that I did, I was having trouble with my workspace finding basic standard messages dependencies. Is this because I have to install it through crates.io? So
No, if
no.
if in the current project you had problems, means the standard message should be in ROS side, so it is strange because it is using the ROS package standard message.
Okay, so must be something else that we cannot debug now. Yeah.
Could be that he cannot include or he didn't include in the cargo toll because it's a dependency that the crate needs,
Ah.
or it could be that it also has to be added in the package dot XML because there we are making the link between the package that Rose like finds with our crate.
Okay, makes sense. Making a lot of sense. Okay, I
Yeah.
have one question here, interesting, from Sorawit that says, what is the difference between the two crates, the ROS to client and RCLRS? It looks like there are two crates. Which one did we use here today?
RLCLRS.
Okay, so it looks like there is another one called ROS to client.
Oh, that's a really good question.
Okay.
I don't know.
You don't know.
I don't know.
Okay, yes. Okay, so that's okay. And then here there is another question here from Angel Lopez that says, I've never heard about Rust until a couple of months when the construct created some courses and live sessions about it. And then he says, why it is becoming so popular all of a sudden?
It's because the efficiency that Rust has and also the memory, how it handles the memory, its memory safety. So by default, when you, it's a bit tricky at the beginning, but after you are designing code that is gonna be safer and regarding memory and performance. That's why people love it.
Okay.
It has been used in robotics and also in like lots of developers use it for different applications.
Okay. Okay, then. So we have another question here from Ruben that says, Rust claims to be memory safe. In C++, we could achieve the same thing using shared pointers and the threads, right?
Yes. Okay. What Rust have, it doesn't have a garbage collector. Okay. What it does is every time you create a code, the compiler assigns to the memory the size of the type of the variable you are using. So the memory, it's always there is the stack and the heap. No? So in the stack you have all the variables, and you know the size of each variable. Okay, so if you want to use pointers, you have to use the heap because you are referenced as a pointer. So it's another way to handle the memory. And I have really good conversations about this. And what I can say is by default, Rust makes you think about the memory. So it's why sometimes the compiler complains because each variable also has an ownership. So you have one variable have one ownership. So if you want to pass the variable to other functions, you lose the ownerships if you are not using references or are not using other kind of. So that's why implicitly it makes you think about the memory.
Aware.
It has been really good design by default. Yeah.
Okay, then I think that that is all. So thank you very much, Júlia, for the amazing project and presentation. Thank you.
Thank you for inviting me.
Here, the round of applause from the audience. Thank you. Cheers, bye.
Yes, thanks a lot, Júlia. Thank you for answering my question as well. Yes, I think it was about the cargo.toml. So thank you about that. And dear attendees, now please take a moment, and there should be a small box in the chat where you should be able to rate the speaker. So please take a moment to rate the speaker, because at the end of the day, we're going to be rating the best speaker based on your votes.
Wow, great. So before the next speaker hits the stage, guess what? I think you know what's gonna happen.
Wait,
You know.
again?
Yes. We have a prize quiz again. So yeah, because we still have some super swag box to give to you guys. So yeah, the winner will have a robotic developer T-shirt, coffee mug, and the stickers. So same. How does it work? And we will watch a 5-minute video about the robotics developer masterclass. And at the end of the video, you will see the question related to the masterclass. So the first person who answers correctly will win the swag box. So you may need to visit the page of the sponsor to get to the answers. So now let's watch the video, and the next speaker will come back in 5 minutes. So
See you soon. All right, everyone, welcome back. Did you get the answer? Love to see the enthusiasm once the swag box comes into play. But before we announce the winner, let's get ready for the next presentation. And again, this means that you're going to have to open another robot project because this is a hands-on interactive session. So please go to the next to the name of the speaker. There should be an open ROSJect button. So please click it. And again, if you have two screens, you can set up the stream on one and the project on the other. And just be patient while it opens up.
So,
Yes,
yeah,
let's go.
So we're gonna go to the winner. So Chessie, who's the winner this time?
So we have the winner already. So the name is Valab SK. Congratulations.
Congratulations. Yes, the correct answer is the tortoise bot.
Nice job, Balab.
So yeah, we will contact you for the shipping details.
Great. And now we are going to talk about simulators and simulations in robotics, because simulations are a very important point in robotics, and we need to use them for practicing before we apply into the real robots. And one of the points of simulations is to create plugins that allow us to extend the capabilities of the simulator. And in this talk, we are going to talk about this, how to create plugins for Gazebo simulation. So our next speaker, Shantanu Parab, is a teaching assistant at University of Maryland. And today, Shantanu will be talking about ROS2 Gazebo custom plugins. And especially, he will be teaching us how to create a plugin to simulate a conveyor belt. Welcome to join Shantanu to the stage. Hello, Shantanu. How are you doing?
I'm doing great. Thank you so much for the introduction, Ricardo.
My pleasure, Shantanu. Everything is ready on your side?
Yes.
Are you easy? So we have some stressful situation preparing with the connection and so on. But
Oh yeah, I had some a connection issue with the password, but I got it figured out. So I'm ready.
Okay. Okay, then can you share please your screen?
Sure.
And then the stage is all yours.
Okay.
Let's go.
So hello everyone. My name is Shantanu Parab. I'm a teaching assistant at UMD, and also I'm an intern at Cross and Robotics. And currently we work on the Aloha kit, and we develop kits for research purposes and mobile manipulators and etc. So yeah, it's a great work. You're working with the robots, and so let's move on to the today's talk, which is creating Gazebo plugins. And how let's first start with the introduction and why do we need it. So while working with Gazebo, you'll often and connecting it with ROS, you'll often come into some situations where certain things are not possible. Like one example here is the link or the joints that are used in Gazebo are quite limited. We don't get something like a conveyor pulley joint, and we are limited to prismatic joints and other rotational joints. So what do we do in such cases is we utilize something called as plugins, and that run in background to make some changes in the simulation environment that will help us to get through the problem that we have. So here in this project, we'll be working on something called as a conveyor belt. A conveyor belt essentially is used for pushing your objects from one end to another and is used in factory settings. So here in this project, we'll be developing one such conveyor belt plugin, which can be used later on in any of your projects. And hopefully you'll get to know a lot about writing your own custom plugins. And let's dive into the objectives and how are we going to set up our entire workspace. So currently you will be having an entire project workspace like this. Also, yeah, so I'll be switching between tabs frequently. Like I have opened 3 tabs. One is for the notebook, one is for the IDE, and one is for the terminal. So just I'll let you know, and so that it's easier for you to follow along. So yeah, In our workspace, the IDE, we'll be having our ROS2 workspace. Inside our ROS2 workspace, we have our package that is called as a conveyor belt package. And inside that package, we have include folders, the launch folders, meshes, scripts, and other folders. So in for this particular demonstration, we'll be just focusing on a few things. That is the include folder for the header files. Next, we'll be moving on to the source folders where we'll be writing the the CPP file for our project. And the rest of the templates are already there, so you don't have to worry about launch files and etc. We'll be talking a little bit about CMake list and package XML. Um, so next, the objective would be like setting the package up. Later, we'll be doing something called as establishing a connection with Gazebo so that we get an idea of how Gazebo is running in the background and how our code reads the Gazebo environment. Next, we'll be utilizing the model that is in the form of a URDF, and we'll be figuring out how we can extract joint information or other link informations from that SDF or a URDF model. Once we are done with that, we can also do certain stuff in the URDF, that like passing arguments or parameters to our plugin. This will be helpful in certain cases. I'll go through that as well later. And then we'll be talking about how can we simulate motion in our robot, or in this case, in our conveyor belt. And lastly, what we'll be doing is, since every time we work with Gazebo, we have to work with ROS to a certain extent, and adding ROS functionality to your Gazebo plugin would be a great advantage for all the ROS developers. So that's how we'll be adding a small topic subscription to our Gazebo plugin so that it can help us to connect with ROS as well. So you can see this GIF that is here, that tells you about what we are expecting from our project. So we'll be having our conveyor belt working. We can turn it on, turn it off, and then we can also spawn a certain object on it, which you can see it would work flawlessly. Before moving on to the details of the project, I would like to highlight a few resources like this. I've listed a few resources that can be helpful for you to learn beyond this project. So I'll highly recommend you to follow the Gazebo API documentation right now if you have time. So you will come across some classes and pointers and other things that might be helpful to understand the code later on. Also, here in this code, I'll be following something called as a PIMPL idiom implementation from C++. It is essentially just hiding the implementation into the source file and keeping the header file as empty as possible. This allows us to like build bigger libraries. So whenever there is a small change in our code, we don't have to recompile the entire library, and it saves a lot of overhead timing while compilation. There are a few other plugins that you can look through and check out later after this demonstration is over. So let us now start with our simulation and look at what is going on in the entire thing. So in order to start your simulation, you have to first set up. So I'll just copy this, quickly go to the terminal. I'll paste it here, and I can source my environment. So that's done. Once that is done, I have to go into my workspace. So that's the roster workspace. Next, we have to build our package. So our package is called the conveyor belt package, and we just paste it here. It's easy. I guess we have to wait for a little while it builds. Yep, it started. So the first initial build would take some time because it is going to build everything from the scratch, but later on, as we just go on adding one stuff at a time, it would be faster. So now we have a clean package that is built, and hopefully everyone is on board with this. We have to source the environment again, the new setup that we have done. Once that is done, we can start with our launch file and we can launch our simulation. All these launch files are already there, so you don't have to worry about how it works and what goes on. There will be different tutorials for this. So our focus here is working with the plugin. So once you start this launch file, hopefully you will be able to see a conveyor belt spawning in an empty gazebo world. Okay, I think. Okay, yeah, it's taking some time. Yeah, once the Gazebo environment boots up for this application, I think it's easier for it to launch. So now you can see there is a Gazebo environment with a conveyor belt inside it. But let's see what happens when we spawn an object over it. So let me just jump to the notebook once. And this is our script to spawn an object. So what we'll do is we'll go back to this terminal, the terminal that we have. We'll open a new tab over here. So before running anything in a new tab, it is essential for us to source the raw environment. So that is what we'll be doing. So we go here, we paste this. Once we have it here, what we'll do is we'll spawn an object. So copy this spawn object on the belt command. It will run a script in the background which spawns an object on the conveyor belt at the exact place where we want it. And in our simulation, you can see there is an object that has spawned on the conveyor belt, but nothing is happening over here. So we are not able to do a lot of stuff over here. So why is it not happening is because we don't have the plugin set up yet. So let's move on step by step and understand how the plugin works, like from the basics and how the update connection and everything works. Let's get into the juicy part. And for that, I'll first stop this simulation so that we don't have anything running in the background. Let's stop this with Control C. Let's go back to the conveyor belt notebook. So here's our folder structure, okay? So if you can see, what we have to do is currently we will be having two missing files. One is the conveyor belt plugin HPP file, the header file, and the conveyor belt plugin CPP file. So these are the two files that we have to put exactly in the following location. So this won't give you errors in the future tutorial. So let's go ahead and make these two files. And in order to make these two files, what I'll do is I'll go here, I'll go into this conveyor belt, I'll click here, new file, and the name of our new file is conveyor belt plugin.hpp. Just so that you don't spell it or do some spelling mistake, make sure you copy it from here, so it would save a lot of time for you. Next, the next file that we need is conveyor belt plugin CPP file. So these two files, we'll make it in the source. So conveyor CPP, right? So we have two files of that we require for designing the plugin. So hopefully, if you have followed till here, your folder structure should look something like this. And let's go ahead and work on these files. So throughout this entire demonstration, the main file that we'll be working on is going to be conveyor belt plugin CPP. But before moving on to that, we'll set up a few things in the package. Like firstly, let's set up the header file. In order to set up the header file, you just have to copy this entire code from your, I'll explain this code in the IDE, and go ahead and put it here in this. So what this code essentially does is it creates a class called as a conveyor belt plugin private class, and it extends it with the Gazebo model plugin. So in this Gazebo model plugin, we have one standard method that is called as a load method, which we inherit from the Gazebo class, the model plugin class. This takes two arguments. One is the model pointer and one is the SDF. So we'll be passing our model, that is a robot, the conveyor belt, as a SDF into these two, and a model in the Gazebo model pointer. This is essential for us so that we can later on figure out which joint we have to pick, or what other transformations do we want to do on a robot. So here, as I said, we'll be using something called as a pointer implementation idiom. So we'll be using this private unique pointer that will be editing, and all the classes that and methods that we'll be creating with are going to be in regards to this, so that we don't have to change the header file again and again. So that's why pointer implementation is quite great for what we are doing, like creating a library. So once this is done here, we have a few common include tags where we are getting the plugin from the Gazebo common library, and yeah, the rest of the stuff will happen in the CPP file. So let's go back to the conveyor belt notebook. In this notebook, you can next you can see is we have to create a CPP file. In the CPP file, we have to add this code. Let's just copy this code and paste it in the ID in the conveyor belt plugin CPP. Okay, so let's understand what's going on in this code a little bit. So we are importing a few libraries, that is model, joint, and then we are also linking it to our header file. And then because we'll be using Gazebo with ROS later, we need a Gazebo ROS node. And since we are also adding a ROS functionality, we'll be using RCL CPP library as well. This is a standard message type that we are importing that will be used later. So these are just the normal imports that we'll be using later on in the tutorial. You don't have to worry about this. This is just definition of some for the looks itself, like it would be color coded, everything would be nicely colored. So that's why we need this. Okay, so yeah, as I said, in our class we have to declare a constructor and a destructor. So here we are creating a constructor which would essentially just tell us that the conveyor belt plugin is initialized. You can use this to debug your plugins later on, like when once is your plugin started, or is there an error, and does the plugin break down. So that this is very essential. Later on, we also have the destructor to know that our plugin has stopped successfully, and then we can end our program. And you will be seeing there is a empty load pointer, sorry, the load method. In this load method, okay, this is better. So this load method is essentially empty, so it won't do anything for now, and we'll be later on updating it to do our functionalities. So, and the important thing is to register our model plugin into the ROS environment. This will help our robot to understand where our model plugin is to be, the plugin is to be found at, and then it would link it to the model in the Gazebo plugin. So I guess everyone is able to follow this until here. Now what we'll do is, yeah, we have to update the CMake list. In order to update the CMake list, we have to make our plugin known to our compiler, so it compiles it when we build our project or the package. So for this, what we'll do is we'll copy this entire stuff from here. We'll go to the IDE. In the IDE, we have to go to the CMake list, and the CMake list would already have a lot of stuff over here. And since you're following the same project as me, you'll be having a line which says put the code copied from the notebook here, and this is where you have to just paste the entire code that you got. So let's just indent it correctly. And this essentially does is it adds the conveyor belt plugin as a library, as a shared library, so that it is available for all the other objects or the packages that you have in your workspace as well. We target this library to the conveyor belt plugin, and then we add some dependencies. For us, the main dependency is the Gazebo ROS, because we have to connect it with ROS and Gazebo. And then we'll be exporting this conveyor belt plugin. And how does this export work and why does it is important is let's first build this project. Yeah, but before building it, we also need to add this plugin to our URDF file, because our robot won't know which plugin is to be used, right? So let's go ahead and copy this. Go to your IDE. In your IDE, open the URDF folder. In this URDF folder, you will be having a conveyor belt URDF.zacro file. So what you do is you scroll down. All this information is already there. It is just for the robots uh, dimensions and others thing. So once you have it, go here and paste it over here. You will already have a comment where you have to copy the code, and make sure you don't copy it below this robot tag, or else it would give you an error. So this plugin is where we are giving the file name. This is the file name that it is going to search in the entire workspace to figure out which plugin it has to use. This is the plugin name that we'll essentially see in the Gazebo environment written like as a name of this plugin, because we can have multiple plugins for the same thing, right? So we can differentiate using a namespace. Next, this is a parameter that we'll be talking later and how to utilize this parameter. Okay. Let me just check if everything's going fine. Okay, yeah. That's good. So later, now we have to, since we have the setup done, we can go ahead and build our project. To build our project, just copy this, go to your terminal and paste it. Okay. So once, okay, let me see. Saved everything. Looks like. This is saved. Okay, this is saved. Okay, let me see what's happening here. It's not throwing an error at all.
Have you tried removing your build and install, Shantanu? I've seen you having
Oh,
some issues there.
okay, I'll just do it. Yeah, I think I'll just open a new tab. That new terminal, that should be fine for this one. Let me just source this environment quickly.
Yeah, that's what I was gonna say. You should compile in your package, in your workspace, sorry.
Yeah, I think I am in the correct workspace. Just correct me if I'm wrong. It says it has a
Maybe
controller.
you can remove the in build. And install also. Yeah, lock is okay, yes.
Okay, this.
So you have some problem in your, let's see the path that says, okay, so now you close this terminal and open, first, before closing, wait. So remove again the build and install. And then close this terminal and open a new one. So it will have the clean source, just in case that something is wrong, because it looks like it's a problem, not. And we can see now. Yes, so you can do a source of opti, ROS. Yes, now this setup. Let's see. And now try to compile again. Let's see if it works. Okay. Can you just go compile everything? It is badly written, by the way. It's badly written. You have a spelling mistake. Okay, so here, why is it making reference to the install? So what do you have? Have you compiling something inside the one of the? So it shouldn't say anything about. Let me see.
That's what I'm.
No. This is automatically generated. So yeah, you have another build, another install there on the top level. I don't know what are those things. You better remove them. On the IDE,
Okay.
on the IDE.
Okay.
Yes.
Oh, I got.
Yeah. So this is wrong.
Oh,
so I don't know what's this doing there. And then what I'm suspecting is that something is also in another directory.
Okay, I was able to get rid of this. This was empty. This is empty. Rid of this as well.
Yeah, I see that you have strange characters in the code. You can see on the IDE, line number 9, for example.
Those
Yes.
yellow squares.
Yeah.
Delete those.
Yeah, you should delete them.
I think they're strange characters.
Yeah, somehow copying this created that. those characters. You need to remove them all from all the place.
Okay, this is quite strange.
Yeah, you should. No, wait. Yeah.
I can just
You can
control
try
S
copying
and
it again. Or this, yeah, there you go.
You have to go to the right and then press backspace. Go to
I
the
think
right
this is
of the
fine.
line. Go to, yeah. Also, yeah. Maybe. Oh, okay. That was clever. Very good.
Awesome.
Yeah. So check the other files also, just in case that something happens. Also in the got the same error.
There you go. Yeah, those do the same thing. Great.
Yes.
Yeah.
And here is.
Okay, yeah. I think this
Well, you got
maybe
there
this is
too. Yeah. This is a copying issue.
Yes.
A lot of people are saying that they were able to build it, so this is most likely it.
Now you need to remove again. Yeah. Remove again.
I think this works.
Okay. Then.
Oh yeah, it was a copying issue.
Okay.
My bad.
Okay, we are back in business, I think.
Yeah,
Go for it. Go for
Sorry
it.
for that delay.
No, it's okay. You are doing excellent. So go ahead, Shantanu. By the way, we have 5 minutes. Okay, left.
Okay, cool. I'll get it done quickly.
Go for it.
Hopefully this builds in time.
Yes, that's one of the problems. But in the meantime, you can tell us about some other plugins that you have been doing. What about other plugins?
Yeah, so okay, this I'll take that later.
Okay,
But yeah,
great,
so
great.
if we have our build done successfully, so because this is already done, let's quickly jump to the sourcing of this, and then while that is being sourced, let's go ahead and jump to launching the. So we won't be looking into the simulation right now because it would take some time. So once you have simulation is correctly set up, you should be getting a line called as initialize the conveyor belt plugin. This essentially tells us that our code is right, our setup is right, and everything is good to go, and we'll work on this, the functionality and the rest of the stuff. So what we'll do is firstly, we have to add a connection pointer because we have to update our code whenever there is an update in the Gazebo environment. So for that, we'll be creating a connection pointer. Let's go ahead and open the CPP file. In the CPP file, you have to go here and say public, and then create some pointer. This is connection. Yeah, so we go public and we create a connection pointer. Once this connection pointer is done, we also need a method. Okay, so this method is essentially we go into the same and we create a method as well. So we have a pointer that connects to the update connection and the method that we'll be working with. What we'll do is in this method we will be copying this, and let's write the method over here. Yeah, it's getting these weird characters when it's copying. Just keep this find command handy. So whenever there is an on update, it would say that a Gazebo world has been updated. Okay. Okay. There is one thing that I have missed over here.
We have to finish, Shantanu.
Okay. So what we'll do is we have to add a in our load class. What we'll do is in a load class, what we'll do is we'll add a implementation to this. And yeah, once this is done, we can also go ahead and quickly build this, and hopefully it takes less time. Okay, while this builds, we'll go ahead and we'll see what we have to do next. We have to figure out that there is a joint called as a belt joint in our URDF folder. In this URDF, what we'll do is we have to fetch that belt joint from as a joint pointer. We'll receive that pointer and store it in this joint pointer thing, and then we'll be acting on it. That is, we'll be implementing the search. Like, firstly, we'll be doing a exception catch where we'll be figuring out if the belt joint really exists in the URDF. If it doesn't, we'll stop the plugin and we'll send a belt joint not found, unable to start conveyor plugin. Once that is done, what we'll do next is we have to figure out the max velocity. So in order to get the max velocity, we'll get the parameter. In order to fetch that parameter, what we'll do is we'll set up some variables firstly. Once those variables are set up, what we next is we can get the upper limit from the joint that we already have. This would give us the max upper limit for the joint as set it up in the SDF file. Once that is done, we can also get the element from the SDF file, that is the max velocity element that is in this tag over here. This gives us the max velocity, and we'll store it in a variable as well. And then let's see if this is done building.
So we don't have time, Shantanu. I think that you have summarized the point in there, and then the people can follow afterwards with the project, continue the instructions, because still need so many steps to be finished. Yes.
Yes. So I'll just go through this project quickly, and then you can follow it later. So what we do here is we get the velocity element and we store it in max velocity variable. Once this is done, what we can see on our screen is the build package is done. We launch the robot. We can get all this information like the loaded model and the SDF. And we also get the max velocity, that would be 0.3, and the max joint limit that is set up by the URDF as 0.01. Later, we want to move the joints. In order to move the joints, we use the methods that are already given in the Gazebo API, which is belt like we get the joint, we use the set velocity method. This set velocity method, we'll be setting the velocity as the belt velocity, which would be here as 0.3. And then we'll be also figuring out what is the belt position from the position method. And once we get that, we'll check if this belt position goes above the limit that we have described. We have to bring the belt back to this original position. So what will happen is the prismatic joint would have a certain linear velocity. It would move forward, and once it goes beyond the limit, it would come back. So once it comes back, it doesn't bring the object that is spawned on the prismatic joint back. It's just the joint that comes back. So it keeps on moving the object forward in the time, as you can see in this video. So in the end, when we have to add a ROS functionality, what we'll do is we'll define a ROS Gazebo ROS shared pointer node, and then we'll also create a RCL CPP subscription to let's say we call it power subscriber, and we'll have a method that is a callback method that changes some variables in our code that stops uh, the conveyor belt.
Yes,
So
by using ROS, right?
Yes.
Exactly.
So
we have to finish, Shantanu. Please wrap up.
Yeah. So finally, when you are able to do all this, what will happen is you can get a conveyor power topic in your ROS topic list. Once this is done, you can send a false or a true signal to your using a command line, and it would turn off or turn on your uh, conveyor belt, and you can see some logging into the terminal saying the conveyor belt is turned off or the conveyor belt is turned on. So I think that's it for
Yes, we can
tutorial. You
finish
can
here.
follow it.
We need to
Yeah.
finish here, Shantanu. I
Yeah.
think that you
Okay.
have
Good.
prepared an
Thanks. This
excellent
was fun.
project. So thank you very much. Thank you. So what's about this image that you are showing us now? That you were showing us
Okay.
this drone thing. What is this?
I think I stopped sharing.
Yes, you
Just
stop sharing, but you can share it again if you want to let us know
yes.
about your image, what it's about. In the meantime, the people can put your question. Please put your question for Shantanu on the Q&A tab that is on the chat here on this side. So select there, or vote for the questions that are already there, and then I will ask them according to the vote to Shantanu. Let's go. We
So
have a few
this.
steps.
So
Yeah, go ahead.
meanwhile,
Yeah.
I'll just explain this plugin. This is also a model plugin. Here, what we essentially are doing is, once we know there is a joint, a link on a robot, we can fetch it and we can do a lot of stuff with it. We can add force to it, add torque to it. So what is happening in this plugin is we are getting the links that are connected to the propeller, and we are pushing it using force and torque, and then we are culminating the entire force and torque and putting it on the base of the drone, so it lifts the drone up. And after some PID and some other fancy control stuff, you can make your robot fly, pick objects, do a lot of crazy stuff. So that's how you can design more plugins and you can utilize the full power of Gazebo and simulations.
Excellent. And do you have the source code open for this also plugins
Yes.
in your
If you
website,
go,
right?
yeah, you can go scroll up and you will be finding some, yeah, in this itself, the drone plugin, and you can figure out like it would be similar to whatever we talked right now, and just a little bit of drone stuff in that.
Okay. Then let me ask you one other question because we have been working here. Can you show yourself so people can see yourself and then recognize you? Then on the streets and in the conferences, they will say, "Oh, that's Shantanu, the famous
Oh, I
guy."
think my
Yes.
s-
So,
screen,
so what
everything
about?
is
Yeah. Sorry.
visible.
Yeah. We can see you now. Excellent. And then
Cool.
Robert Grubersky is asking an interesting question is because
Mm-hmm.
you have been showing these plugins for
Mm-hmm.
Gazebo Classic, but what about
Yeah.
using the same method? Is it possible to use the same for Gazebo Sim, which is the old Ignition Gazebo? So then Ignition Gazebo now is called Gazebo Sim, right? So
Mm-hmm.
so what is the difference between creating plugins for the Gazebo Classic or the new Gazebo?
I think the basics would be all the same. Maybe some methods or you can read through the API for each specific Gazebo environment or the Gazebo versions. But most of the stuff would be same. It would be a version up. Maybe it might be downgraded. One thing I noticed is there would be some changes like in the classes, like maybe it might be ignition, or in some cases it might be math. So in terms of those particular things which are very version specific, you can always rely on the API or the documentation given by the official Gazebo channels. That's what I would suggest.
Okay, and then Alexander Warkus has a question that says, is the workflow the same for creating custom plugins using Python instead of C++? Have you
Okay.
created Python plugins?
So I haven't worked with Python plugins because the majority of the plugins, whenever I have worked with ROS, are all developed in C++. Maybe that's because C++ becomes very handy while giving like sending out the plugins to other people. Like the libraries are quite easier to transfer, and which is a very difficult task in terms of Python. Like you have to set up the environment for the particular code to work. So I think I don't have exact knowledge about what goes in the Python plugin.
Actually, I didn't know that you could write plugins for Gazebo in Python. I thought that was only possible in C++, but
Yeah, that's my thought as well. I've never
okay.
seen a Python plugin
Okay.
anywhere in the ROS documentation so far.
Okay, okay. Then unfortunately, we don't have more time for questions, Shantanu, but
Sure.
it's been a pleasure. Also, the project that you have prepared it's excellent. Then people can that have the copy, then they can follow step by step and finish until the end and get the result. So thank you very much again, Shantanu.
Have a great day. Thank you.
Yes, thank you, Shantanu, very, very much for your Gazebo plugin presentation. Everyone, you should now all be seeing a box in the chat where you can rate the speaker. So please take a moment to rate Shantanu, because again, at the end, one of these speakers will get the best Raw Speaker Award based on your votes.
So don't forget to rate. And before we meet the next speaker, we cannot miss the fun time.
Oh my word, fun again.
Yes, yes. So another prize quiz right now. So the winner again will get this super sweat box with a I'm a robotic developer T-shirt, coffee mug, and the stickers. And this is sponsored by Nav2. So how does it work? The following 5 minutes video is about Nav2. So at the end of the video, you will see a question related to it. And the first person who gets the correct answer in the chat will get the sweat box. So you may need to go to the page of the sponsor to get the answer. So now let's watch the video, and the next speaker will come back in 5 minutes.
See you soon. All right, welcome back. It's time to pick the winner of this one. I noticed that Yogesh Kumar answered with controller. Anton Duck answered a second earlier, but with control with two L's. So Yogesh Kumar, due to the
Purist.
it's the actual answer is controller. So I'm sorry, Anton, but Yogesh, you're gonna be the winner. So congratulations, awesome. You're gonna get a swag box. So our team will get in contact for shipping details. And now, guys, let's get ready to be inspired by our next session, which is a career advice by experts.
Yes, and today we are going to attack the option in career, which is about building educational materials as a possible solution for you to become roboticist and an employee, or to generate your own material. Because today we are going to answer the questions about how do you create quality robotics educational content, how to get revenue from a robotics course, or similar questions. So in this expert careers advice talk, we are going to talk with first with Alberto Esquerro, who is the host of the Robotics Developers Open Class and head of education at the Construct.
Hello there.
And next, we have Anderson Nardin, who is a robotics ambassador who recently has published his first online robotics course, and is here to share his journey into creating this material and publishing it. Welcome, Anderson. Are you there?
Hello, Ricardo. Good to talk to you again.
Yes.
Can you hear me?
Yes, and we can see you. Hello. How you doing, Anderson?
Yes, very fine. Yes, good to see you again.
Excellent. So here we are about to talk about this educational material, how to create educational material, because that's another one of the possible career options, right? And then the first question that I would like to ask you is, what sparked your interest in robotics, Anderson?
Okay, so I really like to talk about this. In fact, when I was just a child, I remember that one of my first memories was about those Japanese TV series that was based on Super Sentais. That was the name. It was basically based on robots that were able to transform, but not just transform, but they could assemble themselves and build different stuff. So I thought
Transformers.
I couldn't imagine any other thing cooler than this. So so that populated my imagination since I was a child, and then at some point when I had to define my career and the thing that I would like to study, robotics was on the top of everything.
Excellent. And now what are you doing? So what is your career so far?
So today I work as a research scientist and an engineer as well, but I'm more focused on different fields like biorobotics and bio-inspired applications. So I still see the whole range of possibilities. I always see the robotics as something that has the potential to improve the work that humans can do. And thinking about saving energy from humans, robots are the perfect piece of technology because it's final M. I know that other speakers talk about this today, but the final M is always to substitute a human in a way. So something that you have there playing our role. So this is the perfect piece of technology, in my opinion.
Okay, but then as a side project, let me call it, you are working or you are acting as a robotics ambassador. So what are your main responsibilities?
Yeah, so in fact, I have been selected as a robotics ambassador, especially due to the language that my mother language and how I could widespread the knowledge. So I feel these responsibilities about how I could make these more democratic and more popular, the knowledge by itself. But I would say that also my responsibilities are not limited to the audience that my language defines, but also when we talk about the possibilities of robotics, I mean, we deal with people, especially in the mainstream, who, as you said today, even you said this, that people are scared about what robots can do, and as an ambassador, I think the responsibility is related to how we cross these bridges, so how you connect the knowledge that is something pretty technical, something that most of the time is not accessible to everybody, but we take this and make this more popular and make something that is accessible to everybody, independently of the language, I would say.
Yeah, so you are spreading the knowledge of robotic, right?
Yes, I like to see myself as an ambassador in this sense.
And so, based on your experience developing material as a robotics ambassador, because you have been building videos, you have been writing posts, and you have recently published your first paid course also, then you have done a lot of material, educational material already. So in your opinion, how good or bad is the education in robotics in general? What is missing that could be a business opportunity for the audience?
Okay, so as a PhD, I attended many courses in many different, several levels. And I could say that I had the privilege of attending courses given by some of the fathers of the field, so like Roy Featherstone, Mark Kutkowski, Bruno Siciliano, many of these, Paulo Dario, they were my professors. So I would say that in general sense, this process of teaching and learning robotics, especially for the basics and for the theory, is very well fundamented, very well based, so very well posted. But I still see some niches, some possibilities when it takes into consideration applications. So in fact, I see that this is transforming. So, for example, if some courses could take a special robot, a special framework, and then you develop your skills into the possibilities of that robot specifically. So this is something that I see a lot in the constructor courses. So it's something that I pretty enjoy. And so what I mean is like the possibilities are more toward those applications and something more practical. You are the interviewer, but I would say that in this case, possibly this is something that motivated you, I think, as the constructor, something that applied the constructivism, something that, in fact, put in practice your knowledge and takes this into consideration, put in place. Yes.
Okay, excellent.
Yeah, so I would like to jump in also to make some questions to Anderson. So you just said that you had created your first course as robotics ambassador with the construct. So I wanted to ask you, what inspired you to create your first course about space robotics? Because that's the topic, right?
Yes, in fact, yeah. So, in fact, when I thought about the topic and how it should be, actually, we were challenged by the promoters of the program that it should be something original, something that we could not find in the construct catalog. And so that was the main challenge, something that represented a big jump. And I knew that if I had to talk about some subject, it should be something that I mastered. So I wouldn't feel confident if I was not talking about something that I really know the nuances, the details of the things. So actually, I had a master and a PhD in space robotics in this field. And my work since then was try to to fit all this information, this massive quantity of information, I was prompted to make it in 5 hours. So you guys, when you proposed this, I mean, it was super interesting because I mean, I learned a lot, and this is the cool stuff about teaching that you also learn while teaching. And but that's it. The choice for the subject was especially due to this, to my own background and something that I felt confident in talking about.
Right. And can you walk us through the process that you went in order to create the course? So which one were the steps? Because many people think that the courses or the books or the movies, they just appear like, oh, one day I go and then I put myself, ticky, 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 and then it goes, and then finished, and then, or I continue tomorrow for the same point. It's not that. So it has a process. And so can you walk us a little bit about that process that you followed?
Yes. So to be sincere, I didn't know in the beginning. I didn't know all the things, all the technical stuff that it was necessary to make the final result. Fortunately, because now, I mean, we had Deconstructor, I had access to all these sources of knowledge. I watched many live classes from Alberto, for example. And then with this, I managed to collect all these pieces. In the beginning, I knew that my course would need to apply a bit of a gamification. I wanted to create a kind of plot. So the story that I had from behind, so for those who doesn't know, in fact, the course that I proposed, it has a story from, so you are a character playing this, you are playing the role of this guy who are trapped in outside of your spacecraft. So in the middle of all of these, I wanted to apply some pieces of gamification here and there, and something that instigates, something that makes the student keen to solve it. And by this, learning the stuff, the technical stuff. So basically, the story is this glue that connects everything, all the technical points around. So humbly, I thought that this would be the best way of approaching.
And then can I ask now a question to Alberto himself? Because then, Anderson is explaining the procedure that he has delivered, but what about you? So you as the head of education at the construct, then you have developed a lot of courses or managed the development of many courses. So can you explain to the audience the process that we follow to the construct so they can understand how much work they will need to put in order to create the courses?
So our approach, Anderson has already explained a little bit of it, but so we try to move away from the, let's say, classical way of teaching, which is just a sequential series of topics one after another. So for instance, let's think of a maths book. It would be chapter 1, equations, chapter 2, derivatives, and then, so you have many things to learn, but why do I want to learn this? So how is all this knowledge going to help me? So we try to go all the other way around. So our approach is to go from a real world application. Let's say, for instance, a robot arm is picking a cup from the table and moving it to another place. Okay? Then what do you need to know in order to be able to create this application? Right? So you need to have some basic knowledge on manipulation, on how the kinematics work. You need to have a way of easily controlling this arm, which would be through Move It. But basically, our approach is to go from the, let's say, from the final robot application for the result that you are going to obtain. And then from that point, we keep moving down and building on all the things that you need to learn in order to reach that end goal.
Okay, so that would be like identifying first what needs to be learned. But then once you have identified, what happens next?
So once so then the whole process, let's say, of creating a course would be let's say, in trying to summarize it, because there are many things there.
Yeah, of course.
But yeah,
Don't have the-
so first we identify one topic, and then once we have that topic, we do a bit of research on that topic, and then we create a general, let's say, index for the course. So, okay, in the chapter 1, I'm going to teach this specific part of the topic, chapter 2 this, chapter 3 this, everything interconnected, but we try to divide things in logical parts. Then once we have the structure of the course, the next thing is to find a simulation that suits that course. What does this mean? This means, for instance, if I want to teach about manipulation, I'm going to first set up a robotic arm simulation. Yeah, because our courses and our way of teaching is hands-on learning. Yeah, so you have to actually do the things that you are learning. You have to apply them directly to a robot. Yeah, in this case, it's a simulated robot, or it can be also a real robot in some cases. But then once we have the index of the course and the simulation set up that we are going to use, it can be also more than one simulation, but well, we have the simulation set up for our course. Then next thing is to actually have something working with that robot, specific to each unit. So if in unit 1 what I want to teach is motion planning with a robotic arm, then I'm going to have something working, first of all, with the simulation. I'm going to build myself the application, the code, to have something working. And then once I have the final result, something working, I'm going to start writing down in the notebook correctly all the things, all the step by step that you need to follow in order to have that final code, final application working.
And the reason behind.
Yeah.
Exactly.
That would be more or less a summary
of summary. Okay. Yeah. So that's a process that is being backwards, as Alberto has mentioned, instead of going first path planning, right? You say path planning, and then you don't know why you are talking about path planning in there until the last unit that say, okay, now we are applying to all those this to make the robot grasp the and maybe you never reach the final unit. Then let me tell you in which strategies do exist in general, okay, to monetize educational content? Because maybe some people of the audience, they are thinking, oh, that's a career line that I would like to go to create educational material. And then, okay, so it's interesting how the construct is doing or how Anderson is doing, but what about me? So how can I create educational content and monetize that? Can you tell us?
Yeah, so there are many approaches. Let's try to go over some of them. For instance, the first one that comes to mind is create YouTube content, YouTube video. So you have some knowledge, and then you can create a video sharing this knowledge in YouTube. And well, you can even monetize in YouTube, but usually what you are going to do is what is known as content marketing. So you can create these YouTube videos, and then with that video, you capture the attention of people who wants to learn, and then maybe you redirect them to some other material, an online course, something like this. Another approach, now that we are talking, is to create directly a course for an online platform. Let's say, I don't know, Udemy, or then you create a series of videos and material like this, and then you can put everything together into an online learning platform. And then there, people can just go there and buy your course.
Exactly, you sell it there.
You sell it there.
Yeah, so there are a lot of people selling courses in Udemy, for example. Udemy is a platform that accepts courses. Yes, and what about those courses from Coursera, which are different because not everybody can go there and publish a course in Coursera, Udacity, for example?
Yeah, in Coursera, at least I have taken a couple, and usually those courses, at least the ones from Coursera that I have taken, are provided by universities. Usually.
Yeah, so you have to be part of the universities.
Yeah,
Somebody
it's not.
It's contacting you on the chat.
So easy.
Okay, great. Let me ask a question to Anderson. Anderson, so what tools and software did you use to create your course?
So during the process of I used the RosJect that I had available and the entire interface of that. eventually, because of the limitation of time and the amount of resources that I could use per day, it was like 8 hours. I imported this workspace that I had there, and then I used my own local machine. I had this there, and then I could continue trying. Because achieving that point required a much more time than I had available. So eventually, I had to test also with this. I used for the general graphics of the thing. I used, for example, I used
Dali.
the image generator from ChatGPT and OpenAI. So for creating these very fancy and attractive graphics that I put, some of them are in my course. So I used Dali. So it was pretty handy to have these two available, and I could do something at this level.
And in order to write the explanations or something that when you are trying to explain, so do you use something else from a Jupyter notebook, right?
In fact, so actually, if you follow the notebook there, so you see everything that is explained, and so you have the technical content merged with this story that guides the students through all the process. So you follow everything on the notebook, and then you can, as we have been seeing here, others applying, but in a way that I could touch this subject. That's something that I know that it was pretty dense and hard.
Okay, great, excellent. I like this idea about the story that you follow, and so it helps to introduce into the reason behind studying this course about the space robotics. And we are going to put a link to your project, your course on the chat. So just in case that somebody wants to have a look and also buy, of course, the course for you. So and they are more than welcome.
Yeah, so just as Anderson has explained it, another way of monetizing your knowledge is create a course for the construct.
Yes, exactly. Of course, that's it. Following the same process that Anderson is, you can create. This option is already available, so you can go to create your own ROSjet. All the audience that are there, you can go my ROSjet area, create a new ROSjet course for publication, and then follow the steps, and then just create it and publish at the end, and that's it. Start winning money.
Yeah, you can set up your own simulation, use one which is already provided by us, and then start writing the material. And if the course that you create is good enough, I'm sure many people is going to buy it.
Yeah, because the simulations that are available, they are already running, so you don't have to modify or do something. You just press and then they appear, and that's it. So that's an advantage. Anderson, I want to ask you also about resource recommendations for the audience. So what resources like books, websites, communities would you recommend to others that are interested in creating educational material?
Educational materials, yeah. So thinking specifically about this, I mean, of course, the internet is full of very good resources and books and everything else. But specifically for creating material and of this type that I created, I would recommend to keep your mind open to ludic and sometimes artistic movements. So, for example, just to be original, I would recommend you to watch the TV movie Rick and Morty. So if you see there, if you see the thing, so it will keep your mind open to possibilities. Especially, I mean, I am a big fan of sci-fi fiction. So keep reading this. So create a relationship with this kind of content, and then this will always be a point to attract people. I mean, you will see, possibly you will notice this. My story has a bit of Asimov touch. It has a Isaac Asimov touch there because I was influenced by his way of describing stuff. So what I will recommend is this, and my recommendation for someone who wants to specifically create this kind of content would be keep your mind open to even artistic expressions.
Okay, excellent. Then, yeah, so about the artistic expression, I want to mention about the video that you have included into the course for the education, where you are explaining the story and so on. It's quite artistic, this one. So if the audience wants to watch the video, then we'll have to buy your course also, of course. And then maybe, Alberto, let me ask him another question. Maybe you can, sure. You can share in the meantime the link to his on the chat, and then maybe so we can make business for Anderson also at the same time. Yeah. So Anderson, let me ask you another question. So about what is your opinion about the impact that large language models will have in education?
Okay. So, in fact, recently I saw an interview from Jensen Huang, the CEO of NVIDIA. He was telling something more like, hey guys, I'm here to talk to you about something that is completely different from what everybody else had been telling up to now. Everybody who came to the stage said that you have to learn programming languages. This is the future, but I am here to talk exactly the opposite. We are leaving this era where this is not necessary anymore, because your natural language will be the new programming language that you know. So my opinion is more or less in the middle. You know, I still believe. I mean, I spend my life learning how to solve from the smallest to the biggest bugs in different programming language. So I still see the importance of knowing what you are doing. But one point is unneglectable about all of this, and the use of LLMs. These will provide from now on, and there's no coming back, for the student by itself, a huge tool, in the sense that in the middle of the process that you are learning something, you can, there are always those points that you misunderstand, those that you don't catch. You are doing whatever you are doing. So you are programming now, and then at some point your professor will use a term. He will say, oh, okay, so you do this, and then you use this constructor, but you don't know what is constructor. And then what do you do? So because of just the little misunderstanding.
This happens to me, many times.
You are apart from understanding something that you are totally able to understand. I mean, your mental skills, you are completely prepared. The only thing that put you apart from understanding the content is that little concept.
Yeah.
So now, what the LLMs, the power that it gives to the students, especially, and that's why we are talking about this subject. At any point, with no shame, you can simply go there and clarify that little misunderstanding that you have, and then the world opens to you again.
Wow.
So you are back on the track.
Wow.
And yeah.
That's a very cool point. I never thought about that. And this is one of my problems, also learning. And that go into a university, for example. So I think I'm not a stupid guy, so I'm a regular guy, I can understand, but I got lost there. And when I go to conferences, and then I analyze it, and it happens like this. So it's something that is said that just disconnects me because I don't know the understanding. Maybe because of the language, maybe because English is not my personal language, or maybe because of I understand the word, but not the actual meaning in the when it is used. Yeah, and then I will apply this thing, so we can have our ChatGPT here open on the side, and then do that. Okay, super cool, yes. Super cool.
Yes, and then you clarify that, and then you are back on the track. So I mean, this is fantastic.
Excellent.
All right, so I would like to make also a couple of questions, Anderson. So first of all, do you have any ideas for future courses or educational material that you would like to create? Something that you really would like to teach?
Or somebody, would you like somebody has created?
Or somebody else,
so,
yeah.
Okay, answering the both questions.
Yeah.
So the things that I would like to approach in the near future is like, in fact, I was a bit frustrated while doing this course that I did. At some point, I was a bit frustrated because I could not go that deep as I wanted. So because I was limited by 5 hours. So I had this expectation of doing, besides the introductory course, intermediate or advanced courses. This is something that I have in mind. But talking about the in general perspective of courses that could be done by someone, even by me or by someone else, something related to cybersecurity applied to robotics. So robotics by itself is a broad field that is composed by knowledge in different areas. And cybersecurity by itself is also another area. And at some point, maybe we are not discussing this at this moment, but there are a lot of vulnerabilities that we create. So we have this. You think about swarms or swarms of robots, or many robots cooperating, or these standards of communication. So all these creates vulnerabilities, and it's necessary a specialist in cybersecurity to understand the vulnerabilities we are creating while solving our problems in robotics. So something that I would like to do, and actually something that interests me a lot, is this intersection between them. Yeah, that's it.
Totally, I totally agree. And also, you were saying that maybe we are not yet so worried about that, but yeah. So each time and this is going to go increasing more and more. So at some point we're going to start living around robots also. So that is going to be also crucial to be able to protect those robots that are around humans from potential attacks. But yeah, this maybe also brings me to the point of future trends in robotics education. So how is going to evolve education in the future? Then here I would like to share a couple of points. Maybe Anderson can add more, but I think that one of the directions where robotics education is going to evolve to is to start creating more project-based and hands-on learning material. Because also Anderson mentioned this at the beginning, that probably the robotics theory is well known, and there is a lot of material, books. So all this area of robotics is, let's say, already discovered, yeah, and already very well covered. A lot of material there, but I think there is a lack still of more project-based and hands-on learning education, in the sense of not only knowing the theory of how a robot moves, how are the kinematics of an arm and so on, or mobile robot kinematics, but actually how to build an application that makes the robot do something useful for the humanity. Yeah, and for this we need to focus more on project-based education, which is something that I think right now it's still in very early stages, and also introducing simulations or real robots into the educational process, so that the things that you develop can be tested into actual robots. This is, for instance, one point I think that education is going to be moving forward to. Yeah.
Totally agree.
Me too. Me too. And actually, in case that you consider creating, because now Anderson and Alberto, they have mentioned several places where the audience can build a business based on education. So creating educational material, which is the subject of this talk. Then Anderson has mentioned, for example, like a very, very clear area where you can create material is on cyber security, exactly, for robotics. So that's a point there that doesn't exist, and then you can have it. And then also Alberto is mentioning, hey, if you create those materials, then make sure that they contain projects. That's also a good point, because that can differentiate it. And then let me just mix everything together. If you want to create projects, you can do it at the construct. So you create the projects at the construct, and then because that allows you to provide the projects to the people without having to download and install and all those things. That's a possibility. I'm just suggesting, okay? I just wanted to take the opportunity to put it the commercial there. Then one final question for you, Anderson. So what advice would you give to someone looking to develop their own educational materials in robotics?
Yeah, so I think this is something that we have already talked. I mean, Ricardo and we talked about this. I mean, I would say that there's always somebody in the world who is interested in knowing what you know. So, in fact, if you have this desire of learning something, this is my recommendation. Would be my last piece of advice. Try to practice teaching this to yourself. So, I mean, to the best that you can. And actually, this is what constitutes one of the techniques of learning techniques. So, is the Feynman technique. So, you try to teach something to yourself, and then when you learn it, so you know. And many programmers, you possibly have heard about this technique. Is the rubber duck technique. I have one here. In my case, it's not a rubber duck specifically, but it is a dinosaur. Basically, this technique is based on explaining to your rubber duck. I don't know who has created this, but anyway, this technique consists in basically explaining the thing, all the content to the rubber duck that you have on your desk. Eventually, your rubber duck will know more coding than you, but this is a risk that you have to. And the fact is that at some point, when you are able to explain this, you got to know. So you will understand. For your courses, for generating the content of your courses, practice with yourself. So explain this to yourself as much as you can. And when you get to the point where you understand that, I mean, to the bottom of your honesty, you can understand it. So for sure, that will be interesting to someone else.
Lovely, yeah. I would add, if I have a moment, also one thing that Anderson has already mentioned, and I think it's a good advice also, is that try to teach by building a story around the knowledge, because a story that kind of helps you go through the material, because in my case, and I think in general, this is something that is very, very helpful and very interesting to add to your teaching skills, to be able to teach while telling a story.
Excellent advice. Then I think that is time for us to finish here the conversation with Anderson and Alberto. Thank you very much, guys.
Really appreciate it. Thank you very much.
And now it's time for the question from the audience. And you can put your questions on the Q&A tab that you can see on the chat on the side. And then we are going to be asking the questions to Anderson and Alberto based on your votes. So you can vote for the question that somebody else has put in there. So let's have a look at these questions there. So the first question from Josh, shall we? So I would like to ask you this to both of you. First, let me ask to Anderson. So on average, how long does it take to create a good material, in your opinion?
Well, so it depends a lot. I mean, as everything in your life, the more that you do, the faster you will become. So, I mean, after defining the level, I would say that if you, I mean, of course, this proportion is not exact, but I would say 5-6 times that you expect that your student would dedicate to this.
Okay.
So every time when I make a course of 10 hours from the constructor, I think that is super valuable, because I know the amount of effort, at least 5 times you spent just to debugging, just for debugging, adjusting, and having everything there. And sometimes things that doesn't make sense, sometimes that breaks. So I know it's a lot of effort that is necessary. So I really respect this. And
Wow.
in fact, yeah,
That's a lot of time. That's a lot. And what about you in your experience, Roberto?
Yeah, so it's a difficult question because it really depends. I mean, it's not the same creating a course which is meant, like the one that Anderson created, which is meant to be completed in 5 hours, for instance, than creating a full long course. For instance, our courses which are meant to be finished in 1 week. So the amount of time is completely different. But yes, I would say that at least to create something, even the shortest course, you would need at least a couple of weeks, I would say. One for preparing, researching, and preparing all the material, and another week to test and make sure that everything is working good. And I have seen a question, if you allow me.
Sure,
Ricardo,
of course.
because there is one here that we should do to Anderson later, but this one I can answer it.
Yeah, sure.
And I think it's interesting. So BRL George is asking, you jump straight to examples or theory first? This is a very interesting point, and in my opinion, is always examples first. I mean, I think it's much more interesting to start showing something working and an application working in a robot, maybe in a simulation, for instance, in case of an online course. You show something working and to create this wow moment to the student. And then he sees something from the very beginning of his learning experience. He's able to run something and see it working on a robot.
Yeah.
And then he says, wow, this is working. So how can I learn how to do this?
Yeah.
And then he's excited. On the other hand, if you start explaining, yes, okay, so ROS2 is a framework which is meant to, you start putting there a bunch of text.
A topic.
Yeah.
This is a topic. You can create a topic like this.
Yeah, I prefer to create always the excitement first through making the student go through some real examples.
Yeah.
And then after you introduce all the theory and what he needs to know to achieve that.
Yes, okay. What do you think? What do
If
you
I
think?
can add something, so I completely agree. So it reminds me a lot the approaches proposed by Piaget and Simon Papet, and so the fathers of the constructivism. So in fact, and this is what I think that the constructor is expert in doing. That you show this. So this is the purpose of what you are going to learn. So yeah, because you want to learn how to do this, and then you will pass through all the process.
Yes, I do agree completely with you too. It's a pity because we don't have other people that disagree, and then we cannot give this other point of view to the audience. But that is right. I completely agree because at the end, most of the documentation that we can see of the courses, in my opinion, they are not written for the students. They are written for the people that have written this for themselves, for the people that already knows. So when you don't remember, you can easily go to the section that goes is this section, and then I have the piece of knowledge that I forgot. And a student is not like that because they don't have those sections in their head. Even if you put it, first there's topics, second is messages, third is, so you get a hierarchy of things that you need to explain. This hierarchy doesn't exist in the mind of the student. Then it has to be on the other way around. So you show the examples and hey, look at, you can do, wow, excited. How can I reach that point? Oh, for this, you need to create a package. Oh, tell me more about this package. But is all that? No. Okay, in the package, you put your code and then you need to connect to the sensor. Yeah, because I want to get the data from the laser. But yeah, for that, you need a topic. Okay, interesting. What is this topic? How do I do that? And that's the unfolding process for, I think.
So Ricardo, if you allow me just
sure. Yes, of course. This is for that. So this is a conversation. Yeah. Go ahead.
Okay, so in fact, I also like the approaches that are more like problem-oriented. It's something that I see a lot of examples in the construct courses. So just to give an example, so sometimes when someone wants to teach object-oriented programming. So it will start talking about something, and then it to try to create some examples, but that is pretty hard. If instead, if at some point the professor will try to introduce the terms like a polymorphism, but why is the student will think, why is this? Why is this necessary?
Yes.
So if you propose something like let's make a game, let's make a video game. So you have this character and then it has these attributes. You think about this. So at some point because you face the problems and you see how hard it can be. So and then think, okay, maybe classes can be so it's like a problem oriented. So when you try to solve it and then you get the solution and then everything sums up in your mind.
Yes, because at that point is when it makes sense to us. Oh, that's why I needed a class, because without it, I couldn't. Yes, exactly. Yes. Okay, then of course the people, the audience can say their opinion on the chat. Okay, please go ahead and say, or on the questions also, if you want to ask a question. Do we have time for more questions? No? Okay, so it's we have to end here. Anderson and Alberto, thank you very much, guys, for sharing your experience. And then that's it for this session. Thank you, Anderson. Thank you, Alberto.
Thank you very much. Thank you.
And now we are going to switch again, and here my colleague Rodrigo is back.
All right, I'm back. I'm
what?
Fast.
For what?
All right, guys. Thanks a lot to Alberto and Anderson. Please remember, you should see a box to rate the speaker. Please take a moment to do so because, again, we need those votes to select the best speaker of this year's conference. And all right, everyone, what a great session we've had so far. Bunch of hands-on learning sessions and career advice. So I hope you're all enjoying it and finding it very insightful.
Absolutely. Now it's time to take a break and recharge. So now we will have a 30-minute dinner break.
Okay.
All right, but wait. This isn't just any ordinary dinner break.
Oh, yes.
Oh, again? And why is that?
Well, because we're going to have another contest.
Wow.
This is a little bit different, though. This time it's sponsored by Usarion and their excellent robot, Rosbot XL.
Rosbot XL is an omnidirectional robot that runs on ROS2. Rosbot XL is a robot with style, equipped with a Raspberry Pi or an NVIDIA Ori Nano and several ports of expansion. The best feature of Rosbot XL is its configurability. You can use it as a mobile platform to integrate other robotic elements like arms, extra sensors, or displays. Rosbot XL comes in different packages that allow different configurations like telepresence, autonomy, or manipulation packages. Any of those configurations makes Rosbot XL an excellent robot for learning and teaching robotics. During the ROS Developers Day, you will find a big discount buying one right now on the button that appears at the bottom right of the screen. Buy one now and get a 20% discount.
All right, so moving on to the contest. Here's how it's going to work, all right? So during this dinner break, you're going to see the Rosbot XL in the cyber world, which is one of the Construct's real robot labs. So your goal in this challenge is to collectively use the chat that you've been using to chat to move the robot from the start of the maze of cyber world to the end of the cyber world. If you make it to the end, all people that participated to achieve the goal will receive 1 month license access to the Construct's robotics courses. So remember, you all have to work together to get from the start to the end using commands forward, backwards, left, and you can
rotate left,
rotate left.
Right.
We're blocking it, but you'll see it.
Yes, we are in the middle of the screen. Maybe you can move us to the other side.
So the commands, this is important. So let's move ourselves.
Yes. And then remember that this contest is live. So what you are seeing on the camera, it's just live, not now, okay? This is just the instructions screen, but when we go into the coffee break, you are going to see the live feed of the robot, and then your commands on the chat will start affecting the robot.
So those are the commands, all right? So forward makes it go forward, pretty self-explanatory. Backwards, left, right, rotate left, and rotate right. Remember, you're gonna have to, start talking to each other so it doesn't start crashing everywhere. And whoever wins, whoever is involved in making it to the end will get 1 month free at the construct.
Wow, that's great. And thanks again for the explanation. So now let's enjoy the robot contest and take time to refresh yourself. So after the dinner break, we will have more advice interviews and more hands-on sessions, as well as many prizes. So stay tuned and we will see you back in 30 minutes.
Yes, enjoy the break and let the robot games begin.